All right, welcome everyone to day 2. We're off to a bit of an auspicious start. Really excited to have everyone here this morning for a really special announcement with our friends from Google. So just to start here, I am going to invite Sabrina from Google to come up and give us some opening remarks.
Hi, everybody, and thank you, Cam. Thank you so much for the warm welcome. Thank you to inviting me to this year's Upper Bound Conference. So I'm Sabrina Jeremiah. I'm the VP and Country Manager in Google in Canada. And, you know, for years, I've been hearing about the buzz that's been surrounding this entire event and this amazing, really amazing, vibrant tech ecosystem that you have blossoming here in Edmonton and across the entire province of Alberta. And I've also heard you have a pretty good hockey team. So go Oilers tonight. I'm all in. I'm very excited about it, and I'm really, really excited to be here and experiencing it firsthand. So we're really fortunate to have some of the key drivers of this ecosystem growth that are joining me on stage shortly, including Minister Glubish. And it's in large part thanks to the work that he and his government have done that has really made Alberta a leader in technology. So Minister Glubish, thank you. You know, your vision, it really has been instrumental in fostering an environment and a place where AI and technology can succeed. So a big thank you. So as many of you know, Canada really has been a leader in AI research. And we've been doing it for years. And we've had a lot of really great work also done here in Edmonton by researchers in the primary research field of AI. But now we have this other point in time where we have this incredible opportunity to translate this really amazing world-class research leadership into widespread adoption. And that's about putting AI to work to make a positive difference in our lives, in our jobs, building stronger, more resilient communities across the country. And the potential is very big. So generative AI alone could boost Alberta's economy by $27 billion, and it could save the average worker over 175 hours a year. And this is according to a report that we commissioned from Public First. But this upside isn't really guaranteed, right? We can't seize this opportunity unless we're preparing our future workforce. So we need to help the students of tomorrow use the AI tools of today. And the good news, and this is great news, is that Canadians really they're up for the challenge. So that same report that we did showed that around 63% of Canadian workers really want this skilling. They want AI skilling. It even goes higher to 72% if you start talking to younger people. And that enthusiasm, that desire to learn, that desire to upskill and learn the tools of today is really what the country needs right now. And so with that today, I'm here to announce that Google.org is providing more than $5 million to the Alberta Machine Intelligence Institute, Amii, to boost AI skills for Canadian post-secondary students to help prepare them for the future of work. And with this funding, Amii is going to establish a national consortium of 25 post-secondary institutions to develop easy-to-use AI curriculum materials for instructors and for students. And it's really allowing the faculty to integrate AI and AI skilling into the existing curriculum. So whether you're planning to become an engineer, a doctor, an artist, or like many of you in this room, an entrepreneur or a leader in business, AI will play a role in your career. And I think this initiative is really about giving basic understanding of AI and giving the tools of tomorrow to the students of today to make them more prepared for the job market after graduation. So importantly for all of you here today, this is going to cultivate our next wave of skilled talent for your organizations and the research initiatives that you're all working on. So our mission at Google, it really is to make AI helpful for everyone. And this announcement is just one step in our commitment to making this vision a reality in Canada. So thank you, and I really look forward to our discussion.
Thank you so much, Sabrina. You know, it's really great to finally be able to talk about this. We've been talking with you and your team about this for a while, and just incredibly excited about the impact that we're going to have together, on the province and the country in just this incredibly important area. As Sabrina mentioned, Alberta's been longtime leaders in artificial intelligence, and a lot of that is because of the deep foundational investment that the province has been making in AI for decades. and one of the people who now leads technology and innovation in the province, and who has been both a longtime supporter in his current role as minister, but before as an investor and as a champion of the tech community writ large in Edmonton and Alberta, is Minister Glubish. And so it's my pleasure to invite Minister Glubish to the podium to make some brief remarks.
Well, thanks, Cam, and thanks, everybody. Good to be here with you today. And thank you, Sabrina, for this great announcement on the curriculum funding. This is going to be a game changer. It's so important. You know, it was just a couple of years ago that AI really burst onto the mainstream consciousness with the development of ChatGPT, and so now, you know, you probably know everybody you talk to is talking about AI in one way, shape, or form. But you guys are all here because you know that Alberta has been a leader in AI research and development long before it was cool, long before it was mainstream. In fact, it was 20 years ago that we invested as a province into what now has become the Alberta Machine Intelligence Institute. And that was when we recruited Dr. Richard Sutton here and built a team around him. And it is that work that began 20 years ago that has led to where we are today as a global powerhouse in AI research. But what comes next? What comes next beyond just research? Well, the challenge that Canada faces over the next number of years is how do we up our game with businesses and governments adopting AI across everything they do to increase their productivity, to solve problems in new ways, to think about new ways to tackle the challenges that the next 10 years are going to hold for us. And so that is why this announcement from Google to partner with Amii and to help fund the development of curriculum to make sure it is integrated across the board in every program is going to be so important. And so as a government, I want you to know that we are invested heavily in making sure that Albertans and Alberta businesses and even the Alberta government are positioned well to succeed, to be rapid adopters of AI. And I'll give you just one example of how we're doing that now, and then I'll look forward to getting into maybe some more in the conversation. But one of the things that we often have to do in the government of Alberta is to develop a privacy impact assessment. So, you know, whatever we might be doing, if we're handling data on any type of topic, we have to file a privacy impact assessment with the Privacy Commissioner. And the work for that usually takes about 2 months of full-time work. Well, my deputy minister, who comes to us just in October of last year, who has a lot of expertise in actually developing AI tools, he helped us build a privacy impact assessment generator that is trained on all of the legislation, all of the regulation, and all of the policy in government that defines a privacy impact assessment. And then he helped us to automate the process to upload what are the data sets we're talking about, who are the people inside of government that are allowed to use it, and what are the purposes that it can be used for. And it can automatically, in minutes, generate that privacy impact assessment. Now you can imagine when the government and every public body, every post-secondary institution, every municipality, every agency, including Amii and Alberta Innovates, whenever they're dealing with this type of information, they have to fill out a privacy impact assessment. If we can give them a tool that is AI empowered, they can let them do it in minutes and guarantee their compliance with the law, how cool is that? So this is one example out of dozens that we're working on at the government of Alberta to be leaders in using AI, and hopefully those types of stories will inspire many folks in the private sector to join us in this pursuit. So the future's bright. Amii and Alberta together are on the forefront of this on the Canadian stage and on the global stage. And thanks so much for being here for Upper Bound. I think it's going to be a great week.
Awesome. Well, thank you very much, Minister. Excited to dive into the conversation. Maybe just kind of one last piece before we dive in. Been really fortunate to work with Google.org and work with the ministry on driving forward. Not just the leadership on the research side of artificial intelligence, but really making sure as we talk about at Amii, we talk about AI for good and for all, and making sure that for all part is deeply ingrained in what we do, and we provide opportunities like that as much as possible. So big thank you. Maybe we can give a round of applause again to Google.org for this investment. All right, with that, we are going to dive in and have a bit of a panel discussion around this. And so maybe to start, and I'm going to ask all of our panelists to answer this one. Right now we are leaders. We talk about this a lot in Canada. We're leaders in AI research, and we're not necessarily leading at the same level on commercialization and adoption. And so, what do we need to do to be able to close this gap and to be able to lead on both of those pillars at the same time and really take advantage of this incredible depth of expertise that we're developing here in the country? So, what do we need to do to drive that forward? And I'll go this way. I'll start with you, Minister.
Sure. Well, thanks, Cam. So the way I look at this is there's some short-term, mid-term, and long-term things that we can be doing. There's no one silver bullet. This has got to be a comprehensive strategy. And so, on the long-term side, I'll start with midterm. On the midterm side, I think this post-secondary curriculum that we've talked about briefly here today is going to be critically important, because the folks who will go through that programming are going to, as soon as they complete that, they're going to be going off to building a business or joining a business or a research project or whatever, and they're going to be using those skills with the benefit of all of that AI training to go and become orders of magnitude more productive. On the long term, we need to also be thinking about how can we integrate similar training that is age appropriate for K-12 students. And I do mean right from kindergarten on up. We need to begin teaching kids what is artificial intelligence, how do these tools work, how will they help us to be more productive in everything we do. And so that's something that we're looking to as a government to lay the groundwork, so that my son, he's in kindergarten right now. I want to make sure that he's learning these skills so that 12 years from now, whatever he does next, he can be prepared for a successful future. On the short term, though, what I really am focused on is how do we lead by example as a government? Because it's true that in Canada we're really lagging in adopting not just AI but technology in general. And as a former venture investor, for me, I know the power of technology. I've seen it. I've benefited from it from the perspective of an investor. And for me, what I'm trying to do is to illustrate to folks out across Alberta to say, if you join us in implementing technologies like this, what that will unlock for you and for your business is going to be so exciting that you'll never want to turn back. And so how do we do that? Well, we tell some stories, some inspirational stories. So for me, that's talking about Alberta's best and brightest technology companies, talking about our best and brightest researchers, and highlighting what are they working on and why is it exciting? Why is it going to change the world? And how is it that AI is a crucial foundational part to what they're doing? And then on top of that, then we need to lead by example as a government adopting these technologies. And so that was why we recruited Janet Alford, who's my new deputy minister, to join us in October, because he's not just a lifelong bureaucrat. He actually isn't a lifelong bureaucrat. He has been an entrepreneur. He has been a technologist. He has built AI tools himself. It's funny. We all go away for the weekend, and then I go back into my constituency to work with my local constituents in Sherwood Park, and then I come back on a Monday, and he's like, "Hey, check out this new tool I built on the weekend," and I published a big video on it on LinkedIn to tell people about this open source platform that I built on AI. And so this is the kind of guy I've got who's helping me on the execution of implementing more technology in the government of Alberta. So I gave the example of the privacy impact assessment. We're using AI tools to automate a lot of our government procurement processes. We're starting in the technology procurement side. And so the more and more that we are able to implement these tools to make the government more productive, I think then we can tell that story, and not only will businesses say, well, if the government can do it, surely I can. But I think the general public will say, okay, this AI stuff that I don't really understand what it is, well, the government used it to do this common sense thing, and now the service that I'm getting is better. Okay, I think I need to pay more attention to this and start looking for ways to integrate it into my own life. So that's kind of a three-step. So lead by example and tell stories about successful stories to get people inspired. Focus on the post-secondary education curriculum to integrate it across the board, and then focus on the K-12 system as well.
Awesome, thanks. Sabrina.
Well, it's a big opportunity, right? Like, this is a transformative technology right now, and the adoption question is broad because it's applicable to everything. It's applicable to government, it's applicable to schooling, it's applicable to business. And I mentioned the upside earlier. It's $230 billion upside just from Gen AI for Canada. But if we're slow in adopting versus our global peer set, it's going to take us longer and we will fall behind. So right now, it's really hard to measure adoption, but Deloitte just came out with a business view, and 26% of Canadian businesses have actually implemented a use case. That's roughly 10 points behind our global peers. I talk to a lot of the leaders in business in Canada. Almost all of them have use cases, right? But it's the point of when they're implementing and when they're scaling them. So if you kind of take back, okay, well, how do we not fall behind? How do we move up? And, we can catch up, right? We can actually start to accelerate. I think your lighthousing is so, so important. It's like finding places where it really works and scaling it. One of the issues that I often see is, I call it pilot paralysis, where you want to spin up 20 different pilots and use cases, and then 3 of them work, but they don't actually make it out of the gates. And I think that's so important, is to scale what works, right? I also think, we need a bold and responsible view. I think like balancing the opportunity and the risk is so important. One of the researches that we've seen is that when you get it in the hands of people, when you get it in the hands of businesses, that fear of the unknown a little bit kind of goes down, and people start using it and understanding the application of it. And getting it into the hands of the leaders of tomorrow, which is what our announcement is about today, is so important, because as they're using it, as they're starting to develop use cases, as they're starting to figure out ways to scale it, that's really important. But we have to do that together, right? Like trying to figure out how to integrate this into the school system. It's a team sport, so getting us all together is really, really important. So I would say, bold and responsible, scale what works, and prepare the leaders of tomorrow with the tools of today.
Thanks, Tamara.
So I think the thing that we have to keep in mind too is, if we're slow in adoption, we're also going to start to slip as being that country that is a beacon for education across the world, right? So we love to talk about how Canada is the second best educated nation in the world, but to the point of what happens if we lag, well, then we're going to start slipping. We also have to start to recognize that regardless of how anybody feels about AI, it's here to stay. And so we have to adapt the way that we teach to the full reality of what it means. We have a tendency in academia to just focus on the ethical side of it, right? Like, don't plagiarize, don't cheat on your assignments, right? Don't use ChatGPT to finish off your work. But there's so much more transformative potential available there to address the challenges that we have in business in general. So we have to move beyond plagiarism and ethics. Those are still very important. They still need to be embedded in curriculum, but we need to move to scaling up different kinds of applications and use cases, different kinds of services that are AI supported, and all of that therefore has to get built into the curriculum. And I know that we're going to talk later probably a little bit about just what some of the challenges are in doing that, but I think that's where some of this, I think, is going to be crucial to really help Canada move forward into this.
Awesome. It's a great lead into my next question for you. There are more and more AI courses out there. So this isn't just, okay, the world needs another AI course. Actually getting it into in-context learning and in-context curriculum, is one of the things we're really excited about this. And one of the things that we think is really important. So it's not just literacy for the sake of literacy, which is still good. We need people to understand this, but it's also literacy in the area that they're interested in, and the combination of the two, the intersection of it. I like to say it's like people who are bilingual, who speak 2 languages, and not just French and English in Canada, but how do you speak bio and AI, health and AI, art and AI at the same time? And so I think that you're grappling with this right now, as an educator, and integrating it into your curriculum. Can you talk a little bit about how you're thinking about that, and how you're thinking about getting this into curriculum in a field that's changing pretty quickly?
So one of the things we're looking at is ways to move beyond the standard, because I'm a tech dean, right? So we're trying to move it beyond the standard computer science idea of we create some code and we launch a platform and away it goes, right? There is much more use case to it than just that. So for example, one of the ways that we're potentially looking at doing AI at NATE is to consider what would it look like to have an interdisciplinary program that looks at the implications and uses of AI across human services. So whether that's government, health, education, social services, right? And in what way can AI, when you can look at those as a lens, help us to extend the reach of the people that we can help, that we can stand up and support, especially in a country as large as ours, right? and help us to really reach into communities that are otherwise getting overlooked. And so we're looking beyond just prompt engineering or just simple writing of code to think about how does it impact businesses and industries and occupations across the realm, and not just within technology development.
Awesome. Minister, you've talked about the direction for AI and how you're integrating AI into the ministry. Can you talk a little bit about AI in the strategy for technology and innovation more broadly in the province and what you're looking at driving forward, and this piece around the integration of AI into almost everything, and how that may impact what the province is driving forward in technology and innovation, period?
Yeah, sure. So, I mean, at a foundational level, you can't have mass adoption of AI if you don't have the AI compute infrastructure. And so that's maybe the foundation of our strategic thinking right now is how do we make sure that in Alberta we have access to secure sovereign compute for government, for our own applications, so that we have complete confidence that all of our data and all of the tools that we're using to train new AI-powered technologies is in a safe and secure environment that we control, that's not at risk of being sucked into a foreign country and embedded into their intellectual property. How do we make sure we're building things in Alberta for the benefits of all Albertans? And so to that end, we have begun investing in some sovereign compute infrastructure. I know that's something you're also working at Amii, which we fully support. So we've set up our first tranche of NVIDIA AI chips into our own little data center. And this way we can do rapid pilot projects of training on sensitive data that the government is a steward of, to build new tools and solve problems in new ways, and know that we can confidently say everything is secure, everything is to our privacy and data ethics standards. But then, where do we go from there? Well, we also want to make sure that Alberta companies have access to sovereign compute, so that if they are building the next generation of a new technology, that they can confidently say that their intellectual property is secure and in their hands, and that none of what they've trained on those engines and in those environments is being sucked into an American company's intellectual property, right? So we can be using some of the open source models on sovereign compute, and then the innovators will have full control over their intellectual property. And that will mean that we're not just building things for the benefit of other countries, we're building things for the benefit of Albertans and of Canadians. And that's going to be, I think, a significant turning point for Alberta and for Canada in terms of technological development and technological adoption. And so that if we figure all of that out, that's the foundational energy that's required in order to power all of the AI applications. Then going forward, I think for us it's just we've seen in the private sector, we've seen what Toby from Shopify published about we are an AI first company now. Everything needs to be looked at through the lens of AI, and if you haven't tried AI to do something first, don't expect me to authorize you to go and hire a new employee. I think that there's always going to be a little bit of differences between how governments do things and how private sector do things. But I think we can take some inspiration from what some of these companies are doing and say, how do we become AI first? How do we look and say, is there a way to use AI to be more efficient at delivering this service as a government? Is there a way to develop new tools that will be really exciting? So I think, in healthcare, we've got lots of opportunity in diagnostic imaging to automate that and to increase the accuracy. There's a lot we can do in terms of predictive analytics to say who's most at risk of a heart attack before it happens, and how do we intervene and help them to mitigate the risk so that they don't end up having that heart attack, they don't end up needing that heart surgery. If we're able to start using the power of AI inside of our healthcare system, we can prevent some of the most costly medical interventions before they even happen, and build significant capacity into an overburdened healthcare system. So for me, I don't look at it as we need to do less in healthcare to get our spending under control. I think we need to do more with less, and the only way to do that is to use AI and to use technology. So I think, just to sum up, if we focus on the foundational infrastructure, the compute infrastructure in a sovereign compute environment, so we can make sure that Alberta and Canada are protected from, and that the innovations we build can be proprietary in the hands of Albertans and Canadians, that's going to be critically important. And then we just need to lead by example by using AI in everything we do. And if we do that, our healthcare system is going to function better. Our justice system is going to function better. Our social services programs are going to become more sustainable, and we can help more people in a more effective manner. Our education system is going to function better. Everything we do as a government is going to be better, and Albertans are going to have a better quality of life. And we'll be able to do that while keeping the lowest taxes in the country.
Awesome. We've talked in the past about trying to get tech talent into government and working on some of the incredible challenges and problems that the government's working on. I feel like now that you can lead with, but we have a bunch of H100s, want to come use our cluster? Maybe the recruiting dial might flip over. Sabrina, it's been really great to work with Google because you guys have been long investors in training, period. And whether that was, early investments in things like digital literacy, in internet literacy, often for, K to 12, and now looking at, AI literacy, I guess maybe a broad thing, why does Google invest so much, in an area that doesn't necessarily, feel like it has a direct line impact to Google? And then why were you really excited about this initiative and investing in this area specifically in Canada?
It's something I'm really passionate about. And, Google's goal is to make AI helpful for everybody. And that starts with understanding what you're dealing with, right? So we've been in the skilling game for quite a while. We have a platform called Grow with Google. If you go to Grow with Google, there's a lot of different courses. But the most popular course for Gen AI, kind of just understanding what it is on Coursera, is the Grow with Google course called Gen AI Essentials. And over 54,000 Canadians have taken it. It's a micro credential. So, I did it, and I did it kind of like in between meetings, and you can do it in less than 8 hours, and it just gives you a foundation. Then there's another one called Prompt Engineering, and you can start to go along. But that first AI Essential one, with these courses, when people take them, we go back to them and we ask them about, well, what have you done since you've taken this course? Have you had any outcomes in your job? And it turns out that 75% of the people who are taking these Grow with Google courses are actually getting a positive career outcome. They're getting a new job, they're doing something different, they're getting a promotion, they're getting a salary increase. And that's the point, right? How do you use training to increase better outcomes for Canadians? It's not about training to check the box. It's training to drive an outcome, right? To have an educated workforce, to increase value, to build new things, to grow new areas of diversification for a company. And I think this is really important, and that's why we invest in it. And, a lot of Canadians want this. It's a new tool. They want to get their hands on it. And what we've been missing, I think, from an ecosystem view is that post-secondary moment, right? Like when you go into school, I have two 14-year-olds, and, right now it is very risk-based for them, where they're kind of worried about using the AI because they're not sure if they're going to get in trouble. And, I have to work with them and be like, you don't have it, you don't write it. You got to use it for co-creation and understanding and brainstorming. And I think these are gnarly problems that we have to figure out together and figure out with government, with educators, with post-secondary institutions, with Amii together. And that is what this $5 million is for. It's actually to start to propel that thinking and to find ways that we can scale how we integrate it into the curriculum and we get it out to students at large. So, Cam, the why we invested in Amii is like you've been in it for a while, right? Like you've had the research, the primary research, you know how to apply it. And now we want to work, with you and all of the amazing post-secondary students and post-secondary institutions to get it out into the hands of folks, because there's a great opportunity to untap, and the workforce of tomorrow is really, really going to need it. So we got to start with the students of today.
I love the lead in to tomorrow. A question I wanted to ask you, we talk a lot about industry and what industry is interested in and what academia as a whole, how are institutions grappling with this. I'd love to chat, for you to talk about students And what are the students asking for? What are you hearing from students about what they feel like they need to be successful, what they need to be able to drive forward their entrepreneurial endeavors, what they're doing, after they graduate? Like, how are you thinking about this, and what are you hearing from students in this environment?
So I think the problem is that the students don't even know what to ask, right? Because for the most part, we're still at a moment where, as I said earlier, they're primarily being told don't use it, or be careful how you use it, or you might get in trouble if you use it. Like, we're doing a lot of the risk avoidance kind of approach instead of the opportunity maximizing approach, right? And part of that is just because creating new curriculum is hard, and it takes time, and it takes a lot of knowledge, and the process of change in a lot of higher education is challenging, right? There's a lot of gates that we have to walk through, and developing curriculum that is future forward, that helps our students get what I call life-sustaining careers, right? Which is exactly what AI will prepare them for, is something that we are still grappling with. And so since we aren't giving them the tools in the and we don't know how to broach the conversations well with them yet, I don't think they even know what they should be asking, right? So they come in knowing, well, I'm told that I should do this thing, or I'm told that I should be in tech because, right? So they're focused on the outcome, but they have no idea of what the process should be to get there. And they shouldn't have to. That should be our role, right? As a higher education institution, that should be our role, to be helping them figure that out. And so that one of the reasons we at NATE are excited about all of this is because it'll increase speed to adoption for the new curriculum. We'll know that it's appropriately vetted by people who would actually help do the hiring afterwards, that would take the graduates from across Canada. And we know that it'll fulfill the needs that we have here in Alberta for what Albertans need in order to be successful too. And then as we go through that process, we'll be able to give the language back to students, especially if we're starting younger than by the time they finish their high school diploma and they're already out in higher ed.
Yeah, I love that. I love the minister mentioned K to 12. Last year we ran a pilot program with teachers in the province, and we ended up working with 400 teachers and getting in front of 50,000 K to 12 students in the province. And this thing of, if we can start early, if both on the them being a part of society, a part of civil society, if we can have them really understand this area and be literate in the area, what we set them out to be as citizens, and then also heading into the workforce, we want them coming into post-secondary pushing, saying like, I want this, give me more of this. Can there be more, or could you do more of this? And maybe get out of that kind of like, okay, what am I allowed to do versus not? I always find the more we can get students to push, the more we kind of innovate together, with them. Sabrina, maybe on that note, kind of building on top of, this workforce that, we do this right, we work together, we have this incredible impact on our workforce. How do you see that impacting industry and businesses across Canada? If we can start to, let's have the most AI literate workforce in the world. What happens to Canada if we do that?
Well, I think it's the AI literate workforce, but also, for me, it's also that you have to have bold goals, right? Like, you have to have a destination of what you want to do it. And AI isn't about just the literacy. It isn't just about the tool. It's to drive a business outcome in business, right? So that $230 billion is for all of you and all the Canadian businesses to unlock an upside potential. And so, there's a lot of different use cases that we've been seeing. We talked earlier about the adoption metrics. They're a bit fuzzy, but I talk to a lot of leaders, a lot of small businesses, big businesses. Almost everybody is trying it. I don't know of many, especially larger companies in Canada, that aren't trying AI. They're just not all scaling it as quickly, and that's at 26% implementation. That's 10 points lower than globally. But where I'm seeing a lot of really bold, value coming out is there's a lot of things going on in back office, call center integrations, really cleaning up process. Coding, massive. I think 75% of engineers are using some sort of form of coding assist. Google actually uses it, and 25% of our code is written with a coding assist. And we've just made our Gemini Code Assist. Actually, there's a version that you can subscribe to, but there's a free version for everybody to use. And I think this boost in productivity in that is absolutely huge. And then there's other areas like marketing and advertising, et cetera. There's a small flower shop that we work with that actually used one of our AI-powered AI-powered tools, which is called PMAX. And, these folks are flower store merchants. They're not technical people, and they helped, they work with the AI, and it helped them actually boost their sales by 10% and return their ad spend, which is like their return on investment on that spend, by 30%. So they're seeing really great outcomes, and I'm very hopeful to not just large businesses adopting, because Canada is a land of, SMBs. It's 98% SMBs. And I think this could be a great tool to level the playing field, that a small business here in Edmonton has the same potential tools to be able to get stuff done as a large business might have had even 18 months ago, right? Like that, some of the tools that they're able to use today actually didn't exist. So I think there's a lot of potential for businesses. We just got to adopt, and we got to scale.
I love all this talk of outcomes. Can I just offer a quick little story to build on that? So, you've talked about some great examples on the small and medium business perspective, but I just want to offer one more from the government side, because it's really important and it's meaningful, and these are the types of stories we're going to be able to tell, practically every week in the upcoming year. So the Department of Infrastructure came to us a little while ago, and they said, we manage tens of thousands of real property locations on behalf of Albertans, whether it be schools, hospitals, or other public facilities. And we do this all through spreadsheets and paper-based processes today, and it's awful. And you can think about thousands of leases, thousands of agreements with counterparties who are using those facilities. It's a nightmare. And so they said, we want to do an RFP to go and hire someone to build a new digital platform that will manage this for us. And this all began a couple of years ago. So it took them about 2 years to scope out what they wanted. The RFP went out. The RFP was really vague, as often is the case when government's doing an RFP for technology. And ultimately, only 2 companies bid on it, both of which were the big 5 consulting companies, household names you would recognize. And the one that was shortlisted as likely to receive the bid, their bid was $57 million. It was going to take them 3 years. Now, in my experience doing this now for 6 years, running the technology backbone of government, I can tell you that was guaranteed going to become $100 million over 6 years. And at the end of the 6 years, what they gave us would have been obsolete. So thank goodness, my deputy took a look at this and said, we're going to kill this. We're not going to go to market with this RFP. We're going to take a couple of weeks and do a little homework and use some AI tools to help us. And what we figured is that we could actually use some AI systems to use some computer vision to monitor the screens, the Excel screens that folks were using, and monitor their workflow. And then we could use an AI agent to interview the folks who were doing the work to say, what do you need the tool to do? What is your workflow? What are you actually doing? What are the problems with your current workflow? What is a preferred outcome of a workflow? And it could automatically then build the roadmap to say, what do we actually have to build and how are we going to build it? And then we can use AI prompt engineering to help us develop the code faster. And so we came back and we said, we can actually do this in 18 months, but we will give you monthly upgrades to your workflow. So within 1 month, you'll already have an improvement in your workflow. And the month after that, it'll get better and better and better. And by 18 months, it'll be done. And you know how much it was going to cost? $5 million. So from 57 to 5 million, we're saving $52 million. We're saving years of time, and we are impacting the productivity of an entire government department right away. This is the power of AI. This is a real world outcome. It is happening in Alberta right now. And so I hope that gets everybody excited to say, this is real, and we're just getting started.
Yeah, you know what? It's hard not to get excited about a 10x and a real example, because everybody talks about 10x engineer, a 10x improvement here, but a lot of those are, we did a study and we could have 10x improvement. Actually seeing it live is incredibly inspiring and impactful. Maybe talking about that, because I think one of the things that you've done with the ministry is that traditionally tech would be in this field of computer science, computer engineering grads would be the ones that are doing AI, and still great, still being led out by a lot of those grads. This is awesome. But when you look across your department, probably not 100% computing science grads. So you're you're having the impact, and this is being driven out by a lot of people who come from various different backgrounds. So can you talk a little bit about how both within the ministry and then maybe across Alberta, you're thinking about driving AI literacy and driving AI, workforce readiness, and seeing this impact maybe like outside of what traditionally people would think as a STEM discipline?
Yeah, so while again, it comes back to the principle of leading by example. So tech and innovation as a government department, we're the tech nerds in government. We're the ones who use technology to get things done for every government department. So we support all of the different departments in government with technology solutions. And so for starters, I want to get every employee in technology and innovation to be comfortable and confident in using AI in everything they do. And so some of those folks, yes, they will have the traditional computer science backgrounds, but a lot of them don't. A lot of them, they might not have even started in our department. They've been civil servants. They've been in public service for their entire career, and they eventually came over to tech and innovation. Well, we can help teach them these tools and help them to, maybe it's going to be in terms of briefing note generation, so that instead of when I ask for a briefing note on a topic to say, what's the latest, greatest on that infrastructure project we're doing, instead of me going to my deputy and saying, can you get me a briefing note, and then he goes to an assistant deputy, and then they go to a few executive directors, and then they go to a few directors, and then 3 weeks later I get a briefing note that 40 people touched before it came to me. Why can't I just say, all that information is in our institutional databases and our systems. Why can't I just say, what's the latest, why can't I query an AI tool that says, what's the latest information on this project? And it could automatically generate it. These are the kinds of things, you don't have to be a computer science, like I'm not a computer science guy. I did a business degree, but I know that I could use that type of a tool to make my time more effective, to use my time more effectively. And so we can have, whether they're writing speeches, whether they are coordinating flights for travel, whether they are doing briefing notes, whether we are developing code, whatever it is that we're doing, we can use AI. And what we did is we're calling it the AI maximalist teams inside of tech and innovation. We started with 50 people, but our goal is to get it to where everybody's a part of an AI maximalist team. And the whole idea is we're equipping you with the tools, we're giving you a mandate, you have a license to go and try things and maybe make a few mistakes along the way. That's okay. That's how innovation happens. And some of the results we're seeing in that in just the first month or so has been really exciting. The goal is we get tech and innovation to 100% adoption inside of our own team, and then we can start working in going to the other ministries and say, yeah, it doesn't matter if you're computer scientists. You're probably not. That's actually a good thing. Let us help you learn how to use these tools in the context of what you are experts in. And so imagine a world where every public servant in the government of Alberta is now proficient in using AI tools. That's going to help to unlock productivity that, 3 or 4 years ago would have been unimaginable. And why does that matter? It means that in all of those areas where we have wait times, in all of those areas where it's a pain to interact with government because there's a long lineup, or it takes a long time to get an approval time, it takes a long time to get a permit, it takes a long time to get an answer on something, you could get instant answers and high quality answers, and you could have a much better experience in dealing with the government, and it won't cost more money from the taxpayer. In fact, it is likely to save a ton of money for the taxpayer. So we can have better services, better turnaround times, better experiences for individual Albertans and Alberta businesses, all while saving the taxpayer money. This is the power of AI in the public service.
I love that mentality. It's very similar to when I talked to ATB about how they start thinking about integrating, when early on they were thinking about integrating AI, and the mentality that they flipped, and we see that companies that succeed at this do this really well, is they flip this bit from come and convince me that you should be able to use this tool to I expect you to use this tool. Here's the guardrail, so you're not just like wandering around without understanding. Here's the guardrails. Within this, I'm expecting you to use that. And we know that not everything's going to be perfect along the way, but within there, you're fine, and I have your back for you to use this. But the flip side is I expect you to use it. And that drove, I thought ATB has done an incredible job at integrating into AI into what they're doing. We've certainly seen, how fast in the last, 6 months your ministry has been driving out internally, and now the impact across government. And two industries that you wouldn't normally say are the fastest technology adopters, banking and government, right? But that mentality, if that mentality works there, I don't think there's an excuse for any other business to have that bit flipped and to be able to really have this mentality of, no, you're expected to use this. And now, here's the guardrails. Now let's see what you can actually impact if you do.
If we can do it in the government of Alberta, anybody can do it. And that's part of my vision, is just lead by example, show people it can be done, and hopefully that will inspire folks to join us in this journey.
Awesome. Well, hey, maybe so as the last question, we will ask the unanswerable question of each of the panelists, which is just, okay, looking ahead, 5+ years, what are the AI skills that we think students are going to need and the workforce is going to need? And what do we need to do to deal with the evolving demands that we know are going to happen over the next 5 years? So tomorrow, I'll start with you get to answer the unanswerable question first.
Okay, so I have to answer an unanswerable question. That's an interesting conundrum. I think for us, it's probably about how can we start to treat AI as a knowledge partner, right? So academics overall are hired and maintain careers as being knowledge experts in a certain area of a discipline that they've studied in or that they have worked in for a while and they now teach in because they want to give back. And so how can we start in our higher ed education in Canada to start to look at and use AI as a knowledge partner for educating and enriching the lives of Canadians through better understanding AI as something that is not just a tool, but also a partner in getting things done and getting fulfilling careers. That's the best I can do for an unanswerable question.
Yeah, great answer to the unanswerable question.
Yeah, I think about this a lot. Again, I have twins, right? And so I have like the A/B test at home with all of this, and they're 14, so they're gonna, we have to figure that out together. But I've said for a while that I think that the skills that are needed, it's like the unicorn of the future of work is a combination of left brain and right brain with a foundation of curiosity and resilience. And I think the left brain, you got to understand the tech, you got to understand your math, you got to understand how this works, right? Because it's really important that you do get this. And, a lot of work involves this. But on the right brain, if you hear everything that, Mr. Glubish, you just talked about everything, it's about change. It's about leading change, and it's a human business. And that's really, really that's the right brain skill, working together, collaboration, problem solving, getting stuff done. It's an adaptive change. And then the curiosity is because it is always going to be learning and it is always going to be changing. So we have to kind of figure out how we learn, how we adapt, how we move with it. And then the resilience, everything is iterative, right? How do you learn? How do you figure out what to scale? How do you figure out what to cancel? How do you figure out what is the bold gold that you're driving and what are you prioritizing? So I think, again, left brain, right brain, unicorn, foundation of curiosity and resilience would be my bet.
Awesome.
So the unanswerable question. I mean, this is a tough one, but I'll take a stab at it. So I would say first, we want to make sure that everyone in Alberta understands both the power and the possibility of these tools so they can be inspired to go and try and find ways to use them to do something exceptional. We need to counterbalance that without scaring them, but we need to counterbalance that by saying, here are the safe and secure ways to do so. Here's why sovereign compute is important. In some instances, you probably don't want to use a commercial tool from OpenAI or one of the other big models. Here are the examples of when you would want to use something that's maybe open source on hardware that you control, or hardware that is sovereign in your home jurisdiction. Perhaps something that Amii's hosting, or perhaps something that we're hosting at Tech and Innovation. So that folks can make smart decisions about, what are they using the tool for and what's the right way to use it. And then I think, so that's kind of one foundational piece. I think a second foundational piece would be just understanding how to use these tools as a companion to help you to understand what is the problem you're trying to solve. So how to use AI to say, help me to define the problem that I'm facing today. Like I have a rough idea of it, but maybe interview me, ask me some questions to help me to better articulate what is the problem I'm trying to solve. Help me to understand the technological landscape that is relevant to that problem. Help me to understand best practices that are relevant to that problem. And then now help me to articulate what I want a solved future state to look like. If I can solve this problem, what do I want it to look like? What do I want that outcome to be? What do I want my experience to be once I've solved that problem? Now help me to understand what are the things I might need to do. Build me a roadmap. Help me to understand how to get there. And what are the skills that I need? What's the expertise I need to draw upon? Who are some of the leaders in the field that I could go to? What kind of skills can I upskill for myself to do this myself? What can AI help me do as a non-technological expert? And then what are the things that maybe I need a technological expert to help me to do? But by using those tools to help us to better understand the problem, better articulate the problem, better articulate our vision, then when we go out and talk to the folks in our network to say, this is what, whether you're going to your investors to say, this is what I want to do and this is why you should entrust me with the budget to do it, whether I need to go to Treasury Board and say, this is what I want to do and I need a budget at Tech and Innovation to go and do it, but here's the return on investment. Or whether it's you're just going to your colleagues to say, this is what we're going to build, and this is what I need you to do, this is what I need you to do, and this is what I'm going to do. Like, at every step of the way, when you actually go to execute, you're going to be more persuasive and just a better storyteller to explain to folks what you're trying to do and what everyone's role needs to be. And that's going to increase the odds of success exponentially.
Awesome. It's really exciting. Again, with this investment from Google, this idea of this base layer, I think is really important. And especially in a world where like everything's iterating more and more quickly, there is no longer a set it and forget it education. You have to constantly be learning. And the exciting part about it is, now with more and more of these language models, you have the ability to have that companion along your learning journey that you probably in the past would have to either go find an expert or see if you can dig in and find the right Reddit thread online to learn something. Now to have that companion to learn alongside you is incredibly important. Well, again, thank you everyone so much for joining us this morning. Maybe perhaps both to our panelists and another big round of applause for Google for their incredible investment in this. Thank you. And thank you so much to our panelists, and we look forward to seeing everybody throughout day 2 of Upper Bound.
Hello, everyone. My name is Abby Azari. I'm an assistant professor at the University of Alberta, as well as a Canada CFI AI chair at Amii, the Alberta Machine Intelligence Institute. And today, I want to talk to you about the work that I'm doing in machine learning for the exploration and scientific understanding of planets, specifically the ones in our solar system. So I just want to start off with just kind of this big picture of kind of how I see machine learning in our field. And how I see it is that planetary science and planetary exploration requires machine learning at this point in time. We have a lot of data. We are often dealing with automated needs for exploring planets, but out-of-the-box methods in particular are insufficient for answering our scientific questions. So kind of applying some of these basic kind of tutorials that you would find about machine learning do not always result in us increasing our understanding about a planetary environment. And so what I want to do today is present to you a vision of how we can kind of alter out-of-the-box methods, how we can include physics, so that we can actually answer the scientific questions that our field of planetary science and exploration are particularly interested in. So to motivate us, I just want to provide an example. And this is an example that I find particularly compelling and illustrates kind of this interplay of machine learning and physical sciences. So in late 2022, the solar wind effectively disappeared through an entire swath of the solar system. Now, what is the solar wind? The solar wind, you can think of it as a flow of charged particles or plasmas that occurs throughout the solar system. It is sourced from our sun, and every planet in our solar system interacts with the solar wind. You can kind of think of it as an ocean that occurs in our solar system. We don't always see it, but every planet is interacting with it, all right? Now, just as a bit of a disclaimer, obviously these diagrams are not going to be to scale. The sun is quite a bit bigger. We're missing Venus and Mercury here, partially because I study Mars a lot and we all live on Earth, all right? So in 2022, late 2022, December, the solar wind effectively disappeared, all right? Now, what this actually looks like in our data sets, this is the data from upstream of Earth. Usually you would expect the protons, or these charged particles that make up the solar wind, to exist between about 4 and 8 particles per cubic centimeter, right? So it's not that dense, but it does exist. But if you look specifically at December 25th to 26th, the proton density that we have measured from a satellite upstream of Earth has effectively gone to 0, right? So this means that the protons have effectively disappeared. Like there is no solar wind carrying particles at this point in time, right? And this changes a lot of what the Earth interacts with in terms of solar wind dynamics. It changes a lot of how we would expect to predict space weather, etc., right? But what I want to focus on is Mars, because the same exact event occurred at Mars, right? The sun is a large object. If the solar wind has a massive density decrease at Earth, you would also get the same thing at Mars, dependent on if they are close in alignment. And in this particular case, in late 2022, they were, right? Now, how we study this is with a mission called MAVEN. MAVEN is the, let's see if I can remember the acronym, the Mars Atmosphere and Volatile Evolution Mission. The main goal of MAVEN is to understand how Mars's atmosphere was potentially lost in the past from studying our observations of Mars today, right? So MAVEN orbits around Mars. This is an example orbit from 2019. And as MAVEN orbits, it passes through the solar wind, which I'm demonstrating here with these arrows. We have a velocity flow of these charged particles that I was talking about before. And as MAVEN orbits around, it rotates between measuring the solar wind and then measuring what is happening downstream from the planet, right? And so this bow shock characteristic that I've shown here, that is because, kind of similar to how the solar wind can be thought of as a fluid flow, Mars can be thought of as a boat existing on this fluid flow, or this ocean of solar wind. If you've ever gone in a boat on the ocean before, there's a shock front that forms in front of your boat. That is effectively the same thing that is happening with this bow shock. Now, MAVEN has existed around Mars since 2014. Right? This is now approaching over a decade of measurements. We have over 20,000 orbits that all kind of process around the planet, so they're measuring different locations around the planet. And they're all measuring kind of this combination of solar wind, downstream effects, 20,000 times, right? So if you have an event like the disappearing solar wind event that I talked about before, why can't you just use the suite of instruments that we have on board MAVEN to study that, all right? So MAVEN is, I like to think of it as a large data collector. There are multiple different instruments that are all collecting different types of observations. We can get magnetic field observations, we can get plasma wave observations, we can study the neutral atmosphere, we can study the charged atmosphere or the ionosphere. And with all of that, we have a ton of data in which we can kind of create large statistical pictures. And that is often what our field does in this case, where what I'm showing here is from a previous work where we took all of the MAVEN data that we had, and we created kind of this three-dimensional picture of what we think is happening in that space. And so these colorful lines basically connecting a vector field just by tracing. And this type of study is very useful to do. So why don't we just do statistics and machine learning to study this type of event? We have 20,000 orbits. Why can't we just apply some, clustering algorithms, et cetera? And the reason why is because we don't actually have all the information that we need, all right? So the thing about space environments, the thing about planetary science, is that these are big systems. And one of the problems with applying machine learning is that we can't always quantify everything that matters. And one of the things that matters is the sun in this case. And our sun is dynamic. And in particular, it has a dynamicism that has a peak every 11 years. So on the left, what we're looking at is the sun in 2019. This is from the Solar Dynamics Observatory, so this is real data from our sun. And the video is not going to show again. In 2019, we had a very quiescent sun. It was during solar minimum. In 2024, we had a very active sun. This was during solar maximum. And we are relatively confident that solar maximum corresponds to when the sun's internal magnetic field is reversing. All right. So normally the sun has a dipolar magnetic field, but every 11 years it reverses. And during that reversal, the magnetic field becomes extremely chaotic. Right. Now we can't see magnetic fields, but if you could, it would roughly look something like this. Where on the left we have a pretty dipolar configuration. Magnetic field is leaving from the north, coming in from the south. And every 11 years, this dipolar field reverses, right? And during that reversal, it becomes incredibly chaotic, right? And so we have this extremely chaotic magnetic field orientation, for example, on the right here. And this chaotic orientation creates these little clusters of very intense magnetic fields. This keeps the plasma environment of the sun quite cool. If you look at the sun during an active period, you will see sunspots, right? Now, you can see these with your naked eye. I do not recommend it. I highly do not recommend looking at the sun with your naked eye. But oftentimes how we track if we're in solar minimum or solar maximum is that we count sunspots, right? And we have been doing this for a very long time. Okay. So you might notice it's 2024. As a bit of a preview, we are in solar maximum right now. All right. Now, what happens during solar maximum? You have more sunspots, you have more chaotic magnetic field, and that drives events throughout the solar system. All right. So during May 2024, so very recently, we had one of the largest geomagnetic storms on Earth in the last 30 years. Right? This geomagnetic storm drove a ton of auroras that most people in Canada should have been able to see with their naked eye. If you are particularly interested in the aurora, you might have gone out and seen them like I did, which is where these pictures are from. So these are pictures of the aurora in Manning Park in British Columbia, and those were taken with just a normal cell phone. Right. Now, the kind of operational study of how the sun impacts planets is known as space weather, and the most positive aspect of space weather for humanity is these beautiful light shows in the aurora. However, space weather does have particularly negative effects on Earth's power grid. It can disrupt satellite operations. It can deorbit satellites in particularly problematic ways, waste a lot of money because if you launch a satellite, you want it to stay up, all right? But at Mars, we're particularly interested in how these kind of rare solar weather events or space weather events are going to affect our planets, right? So as I mentioned before, you can track the solar cycle with sunspot numbers, right? I'm showing you the record up until kind of the early 1980s, the mid-1970s. However, this record goes back pretty well estimated until the mid-1700s, right? So sunspot tracking is something that you can do with very limited observational equipment. So you can take this record back quite a bit. And you can see that we are in solar max right now. Kind of the pink curve on your right is what we think is going to happen. So these are predictive models. But where we are right now is kind of this 2025 early to mid zone, right? And you can see, some solar cycles are larger than others. Sometimes the activity is higher. But in 2014, this mission to Mars arrived, right, which is this kind of dashed line here. And then the event, the disappearing solar wind event that I was talking about, where the solar wind disappeared, is kind of late 2022, right? And the thing about that is if you're trying to build some model based off of prior observations, you have never actually seen the same time in solar cycle before this event occurred. Right? So this is the rising phase of the solar cycle. We were not there when MAVEN arrived. Right? So this is the first time that you're in this particular parameter regime. It's the first time that Mars has been driven in the same way. And so successfully building a flexible data-focused model, you need sufficient observations over the entirety of your parameter space that you're interested in. And quite frankly, we just don't have it. Right? 10 years is a lot of data, but it's just not enough in the parameter space that we actually care about, that we know matters. Right? And so this is kind of this ubiquitous problem in planetary science, where we have a lot of data, we have to use it in an automated way, but this data set is inherently sparse. Maybe we weren't in the right place over the planet at the right time. Maybe the sun was in a different part of its phase, and therefore building some sort of kind of data-focused model is just not going to allow you to have the insights that you want to have about this particular event. So what do we do instead? As a field, ooh, we get some music. So we're not going to play that because it's actually a little loud, but we're going to skip ahead a little bit. So as a field, we tend to build these large physics-based models. On the previous slide, if the video was not as loud as I would have preferred, you would have seen this time-dependent simulation in three-dimensional space, where we're solving some sort of physics-based equation. In our field, we tend to focus on fluid dynamics and electricity and magnetism equations. And that combination describes the space environments of planets that we actually want to study. Okay? And this tends to be how we address questions like what happened here, how related is that to what happened over there, right? And that's exactly what we did for this particular event. So these are model representations with some artistic interpretation as well of what happened around Mars during this solar wind event, both before, so a nominal condition, and then after, or this very abnormal condition. And along these orbits, we have these kind of fringe, kind of fur-like vectors. That is our ion density, okay? And so what we can see is that the ion density changed significantly between these two events. We found that out with this physics-based model from one of my collaborators at UCLA, Ying-Jean Ma. And with this type of kind of scientific modeling effort, we were able to make some conclusions about the system. All right. But at this point, you're probably asking, this is a machine learning talk, where is the machine learning here? And I want to take this a little bit further and say, what if we want to extend our understanding a little bit deeper? So what if we want to ask, what model parameters actually best describe our data? Or better put, what set of model parameters best describe our observations? If we are able to answer that, then we can better use our physics-based models to the extent that we have the capacity to, right? Now, there's a bit of a problem with this, and that is that the physics-based models that we run, so those models that I was showing you before, they are computationally intensive, right? So one run, so one parameter input of that physics-based model might take a day, 2 days, 3 days, possibly up to a month on the best supercomputers that we have access to. And additionally, our observations are quite limited or sparse. So as you remember I was saying, this is the first time we've seen this type of event because it's the first time we're in this particular phase of the solar cycle. And so you're also limited on the data side, okay? So if we want to, in this case for Mars science, estimate which distributions of model parameters, i.e. the physical conditions that we're interested in, describe our limited observations, right? Then we have inherently a problem. It's simply just too computationally intensive to actively solve this. If you are kind of frequenting the geophysics space, this is often known as an inverse problem, okay, where you are actually trying to figure out not the forward, but the inverse of this particular estimate. So how we are currently solving this in the field and how I would like for us to kind of continue solving this in the field is that you can run your physics-based model over a varying set of parameters. You can then create an emulation of your physics-based model, so you can train an emulation with machine learning. And there's a lot of different models that you could put in here. And then finally, once you have an emulator that runs faster, you can solve this effectively through sampling, or you can treat it like a Bayesian inverse problem. And this gives you the ability to really put your physical model to work, right? So I want to be clear here, this cannot effectively replace physics-based modeling. You still need them to create emulations. But what it does do is it enables us to solve questions in the field that we have not been able to before. Oftentimes we'll run maybe 5 to 10 model runs, and that's all you have time for. With this type of chain, you can actually inquire to a lot of the different physics that is happening in the system, right? So my research focus in this particular area has been in including additional uncertainties, right? So as a physics-minded person, kind of creating emulations of your very high accuracy, high fidelity physics-based model makes me a little bit concerned. And so my focus has been, what if you have an emulator that is aware of when it is wrong, right? Or aware of its own uncertainty about this emulation chain, and then you include that uncertainty in your final estimation, then effectively you are able to go ahead with your physical conclusions, right? And so I want to give you a preview of what this looks like, right? And before I give you a preview, I just kind of want to take a step back and say, this is a common problem in the physical sciences, right? We often have physics-based models which are expensive. This creates a bottleneck in a lot of the types of questions that we're interested in answering. So for example, if you want to estimate the solar wind conditions at Mars, if you want to estimate what is inside different planets, what does the core of Mars look like? What does the ocean underneath Europa look like? The way that we do that is with physics-based models and running different inverse problems. This enables us to actually get deeper into the science that we're interested in doing, right? Now, unfortunately, the PowerPoint conversion between my computer and the presentation computer did not work. So you'll see that the data and my uncertainties are missing. So I have to take my word for it. And you'll have to imagine that this particular match between our data and our predictive model is actually really good. And so after, you can ask to look at it on my computer. But this is the case that we were running this simulation-based inference problem on, where what I'm showing you with this like cone-like figure is an orbit of MAVEN. And as MAVEN progressed around its orbit, it saw a specific event that occurred between 11 a.m. and 12 p.m., where our observations changed. And our question was, why did they change, all right? So one of the first things we did was we estimated, okay, well, how well does our physics-based model plus machine learning model? So these solid lines are actually our emulated or forward model from the machine learning emulation. How well do they match the data? If you could see, they did match the data quite well. But really, the point of this entire chain was to be able to estimate what type of physical parameters actually described that match, right? So again, this is another PowerPoint conversion issue. But what we're seeing here with these solid lines is right at that time of transition, our emulated model of our physics-based model would estimate that the conditions that we're interested in, and I'm showing you multiple physical parameters that we were interested in, did in fact change at that time, all right? And what's particularly nice about this application, which unfortunately you can't see, is every single one of these lines have an uncertainty envelope on them. And that uncertainty envelope gives us understanding about how confident we are, because we don't actually have a lot of data. And so there is going to be some inherent uncertainty in problems like this, right? So this type of method is not just useful for Mars. You can additionally run different types of planetary environments through this. So this is another example where instead of saying we have some data that we're interested in matching, what if we say instead, what is our possibility of success if we send a mission to a specific planetary space environment? In this case, I'm showing you Europa. We have several physical models of Europa. And what is the chance of a spacecraft trajectory, so this dashed line, actually being able to recover what Europa's atmospheric surface density and scale height are? Now, the reason why we're interested in those two quantities is that tells us how potentially life-supporting a planet like Europa could be, right? Would we expect to see different types of life forms, microbes, etc., on a system like Europa? Well, we would answer that particular question if we are able to estimate the atmospheric compositions, its density, and with that, we can answer questions like, what is potentially underneath the surface, right? So this particular method is extremely useful for estimating what is the possibility of success for future planetary missions, right? Now, with that kind of deep dive into this very kind of subset of the field, I want to give you a broader picture of an overview of how people are using machine learning in planetary science. So I've shown you one particular case. I now want to show you some other cases that people are pursuing and where I see kind of the field going in the future, right? So the reason why I started using machine learning, and I think a lot of people in my field are interested in using machine learning as well, is because, quite frankly, we are drowning in massive data sets, right? So I would peg the beginning of our field to starting in about the 1970s. This is when specifically in situ observations were obtained from other planets. The Voyager spacecraft are very famous, and those are kind of what I would consider a hallmark of in situ planetary exploration. The data size of the Voyager spacecraft is about 100 gigabytes. It's not that large, right? So you can truly go through the entirety of the Voyager data set with your eyes and just kind of look at everything. And that is often what we do as scientists. But if you leapfrog to the modern era, we have missions like the Mars Reconnaissance Orbiter, as well as MAVEN, which are now collecting more data than missions of the past all combined, all right? So these are massive data sets, and these are really pushing us to consider how we can use automated methods, machine learning or otherwise, to kind of inform our scientific understanding, right? Now, planetary science is not particularly the most data-rich, as we've kind of discussed before. We're missing certain parameter regimes. If you expand your view to kind of all of space and Earth science, you have missions like MMS, which is a mission at Earth. This is collecting about 13 gigabytes of data per day. So every day, we are collecting more and more data. This is actually a mission of 4 distinct spacecraft. Then we have missions like the Solar Dynamics Observatory. That's where those solar pictures, those solar videos were coming from. This is collecting about 1,500 gigabytes of data per day. And then if you leapfrog into Earth observations and climate science, we now have missions like the Sentinel series, which are collecting 20,000 gigabytes or 20 terabytes of data per day, right? So these are really pushing us as a field to consider how we can start to include machine learning in just our normal scientific process, right? And at a very kind of high level, how we tend to work is we will formulate some type of hypothesis, a question. We will then investigate that answer with several different methods. We have kind of the classic experimental and observational methods, telescopes, spacecraft, those kind of fall into there. We have theory, i.e. mathematics and how we can kind of describe physical systems. We have computation, those physics-based models I've been talking a lot about. And then finally, we have data science, right? And data science in particular is a kind of emerging area that we are considering how best to use these methods to describe our systems, right? So with this in mind, then, how are we actually using kind of data science and planetary science? And the answer is in a lot of different ways, right? So we can do pre-mission planning So this is like if you sent a spacecraft to a specific object, say Europa, what is your probability of recovering what you thought you should recover, right? Where should you send a spacecraft? If you have, say, a rover on Earth, how analogous would that be to what you would see on Mars, right? And so pre-mission planning is where a lot of activity is happening for machine learning. There is also a significant amount of attention in mission operations. So this is stuff like, because you're really far away, you're not going to be able to operate with a human in the loop. You'll have to have some type of time lag, right? So this is autonomous operations. It's also, you can prioritize different observations as well. Let's say you saw something interesting. Because humans are far away, you need a way of dynamically and automatically saying what is interesting without asking a human, right? And then finally, we have kind of bread and butter science, which is post-mission analyses, right? And post-mission analyses are kind of what you would consider to be most of the focus in the field right now, which is including data into physical models, including machine learning into physical models, resolving kind of what we understand about the system, describing these large physical systems, as well as kind of using the amount of data sets that we have to better describe kind of our scientific understanding, all right? And from about 1995 onwards, kind of similar to other fields, planetary science has seen an increase in the use of machine learning. And so what these lines are showing you is the 4 NASA-represented science domains: planetary science, earth science, heliophysics, so this includes space weather and space physics, and then astrophysics. And over the last several decades, we've seen that the use of machine learning has increased. But I want to point out that planetary science has not seen the same type of increase, right? And in particular, if you kind of run the numbers, we would estimate that it's about half as much as other fields that have analogous types of data sets, right? So earth science data sets are very similar to planetary science data sets. And so the question is kind of, why is this happening? And I would pose that the answer is that our data sets are large but sparse. We don't always have those types of measurements that we'd want. The sun has an 11-year cycle. You have only been in orbit for 10 years, right? So like these types of questions about sparsity, about how you would include physics-based information, have become very important in planetary science. And they have really driven kind of the machine learning users in our field to start to consider how we can incorporate physics-based models, right? And so how I like to think about this type of regime is that we want to be able to include our physics-based understanding as much as possible, right? But we want to also include as much of the data sets that we have available to inform our understanding. And you can think of this as this spectrum, where on one side you'll have a completely model-bound or a theory-based type of approach. So this would be running physics-based models. So on your left, an example of this would be the type of physics-based model that I was showing you earlier for understanding a plasma environment, right? And then on the right would have, you don't necessarily care what type of model representation you have, but you do care about its predictive capability, right? Then you want something that is very informed about the data that you have, but you can have a bit more flexibility in the type of model. And a classic type of application of this is, say, you want to forecast solar flares for humans on Earth. A good way of doing that is truly deep learning at this point in time, all right? So this in-between area, I think, is particularly rewarding for us, where your goal is really to increase the transparency in your findings. You want to include what physics-based knowledge you already have, right? We've built this up for the last several centuries, and it's worthwhile to include that. And this has been kind of renamed, reinterpreted a lot. I like to consider it model-adjusted machine learning, right? So you're literally adjusting models. But this has also been discussed as theory-guided, interpretable, which is much more of a common term these days, physics-informed, which is also very common, or domain-aware, all right? And this is really where I see the field going for planetary science in particular, right? And so with that, I'll leave you kind of with this perspective, which is we have a lot of data, we have to be using machine learning, but current out-of-the-box methods are insufficient without significant alteration for answering most of our scientific questions, which I think we can do, all right? So with that, I will take questions in the remaining approximately 11 minutes. I don't actually know how we take questions.
I think it's over here.
Ah, thank you.
Hi. As a fellow physics nerd, hi.
Hi, welcome.
So, hey, I assume some of your physics-informed models, we're talking the combination of Navier-Stokes, Maxwell, and GR, and maybe a few others peppered into the mix too. Computationally intense, tensor, vector. Those models, very well understood, computationally intense, as you've said. One area I've kind of played with in the industry I work in, just dabbled really, not into the same data depth as you do, is, as you said, kind of sampling that parameter space out and then trying to inform whether it's a neural network or classical statistical machine learning to emulate in a more faster regime. Now, are you using the complete model and trying to sample out that space? Or are you using subset models to sample out their parameter spaces and then combining them together to orchestrate, and understanding there are error bands, like every time you twiddle the knobs in the parameter space?
Yeah.
Yeah, just, holistic or a subset.
Yeah, so what I showed you here is very much a subset. Some of the work that we're doing now is the full three-dimensional model. So the thing about these models is we are interested in the spatial correlations between different grid cells, and so you do want to have the entirety of the physics-based space to emulate it successfully, right? So like, if hypothetically you actually want a different spacecraft trajectory, then if you've only emulated a part of the model, you're not going to really be able to use it as well as if you had done the whole thing originally. So some of the work that I've been doing very recently is using scalable Gaussian processes with some collaborators of mine at University of British Columbia to rapidly estimate with uncertainties these full three-dimensional spaces. And it is wildly computationally expensive, but estimating those uncertainties is something that I think we need to do if we're going to be emulating.
Little follow-up in the tiny industry I work in oil and gas. When we have to run, say, the Navier-Stokes or fracture mechanics or other things, we've got decades where we've run these models. Have we been good at collecting and curating that corpus of information? Sometimes yes, more often we're getting better at it, to then kind of train on the subsets and then kind of have that pairwise emulator like that backwards calculation where you're pre-emulating, here's what I'm seeing, what fits the model. Is it a well-sampled space? If I do nearest neighbors, KNNs, or whatever else, am I in a well-sampled data set or am I not? If I'm not, can I now run my more expensive physics models to populate that space out and make it better overall going forward? I don't know if there is a question in there, I'm just talking.
Yeah, so I think to kind of summarize it a little bit with a kind of overview for people, kind of preset runs will only take you so far. You want to be able to dynamically pick where you would actually run a true physics-based model so that you can have this trade-off between high fidelity and low fidelity models, and that would be kind of the ultimate virtuous scheme for something like this.
The
right?
dynamic feedback, yeah.
A dynamic system where you're saying like, oh, well, the uncertainty is very high here. We actively want to run a new model run here, and that is something that we've been looking in. So, yes.
Thank you
It's a
for
good
answering
idea.
the question I didn't know I had.
Yeah.
Thanks.
Hi, awesome talk. I was kind of wondering what your general strategy is for dealing with, for example, emulators are notoriously bad at not actually obeying physical constraints like mass conservation or your divergence-free conditions, stuff like that. So how do you know what data to actually trust from your emulator versus what you should just throw out because the magnetic field was not divergence-free 5 minutes ago? So.
Yeah, so there's I'll answer it in a non-machine learning way and then a machine learning way. The non-machine learning way is that we are working significantly with modelers in order to only run these types of systems where we truly believe that first, the model is actively a good description of our observations, right? So models themselves don't always fully describe your observations, and so you do need to be a little bit careful of that. It's also possible that you can push a model into a parameter regime where it's not numerically stable, and so you need to be very careful about that as well. So the kind of non-machine learning answer is that we're working with domain experts to make sure that we only run these types of systems where we can trust the results. The other answer is we're including uncertainties. And then the final answer is that we've started looking into constraints, regularizing our emulators to make sure that they would follow some of the very basic conservation quantities that we're interested in, right? So merging that subset of emulators with the physical models, which are highly constrained. Right?
Okay, cool, thank you.
Thank you.
Hi, really nice talk. So I think I'll be just having a follow-up question from the previous question. So like if you have a time series or time-dependent simulations, if you have a, say, surrogate model or say that the emulator that you are using, when do you expect these emulators to be, say, have kicking in the time series simulations, or you would like to do, say, a longer time series with true simulations, or you can decide which ratio of these emulators versus the true simulations to have?
Yeah, so time-dependent simulations are kind of the next, I would say, focus of this work. We have currently been focused on simulations that you'll run until a steady state scenario. So you'll have a parameter, and then you will run that model forward in time until the solution has effectively converged to your final solution. That is a much easier problem. So we're handling it on the physics side, on the model side. We are interested in doing time-dependent simulations. That is a little bit more tricky. I am interested in ideas that people have.
Yeah, because we are having a similar situation. So we are material scientists, and we have a similar problem in that case. Probably.
Yeah, it's a particularly tricky issue because the solution does, change based off of time. Right now, we have moderately made a physics-based assumption to get around that, right? And so as a field, we often will run a model into a steady state condition, and that is then what we choose to emulate. But that doesn't really cut it for systems that are very dynamic and time-dependent, right? Mm-hmm. And so, I'd be interested in hearing what you have to say after.
Yeah, thank you.
Mm-hmm.
Hi, thanks for the talk. Just a quick question that's related to OML. You mentioned 11-year cycles of reversal of polarity. Does that also correspond to higher temperature on Earth when there's a chaotic solar activity?
Yeah, so there's a lot of, I would say, deep modeling, and not by deep learning, but just intellectually deep modeling in solar impacts to, I would say, kind of climate dynamics. To our best understanding, there are some obvious impacts. The sun is a massive source of heat. And you will go back into the records of solar cycles and you'll see distinct periods that some of which are kind of known, such as the Maunder minimum, where sunspots were very, very weak. We don't necessarily know what was happening with the sun at that time. Extending the climate record back to that period is very tricky. And so there is research into that. I would say as a percentage of impact, the kind of specific amount of sunspots versus Earth temperatures is not a huge amount of driving. There are other physical quantities that we would be more interested in than sunspot number. And I would say that's an ongoing point of research, but to our kind of best understanding, most of the kind of recent increase of temperatures is truly human driven. So, other questions? Otherwise, we can take a 2-minute break. And I think I'm actually maybe possibly over. The timer says orange. So with that, come find me after if you have any questions. Thank you.
Welcome to this session on Workforce AI Insights with the Conference Board of Canada. My name is Anahita Dusti. I'm a machine learning educator with the Amii training team. And today I have the pleasure of introducing our next speaker. If you were here yesterday, you might be familiar with him. His session yesterday was on AI adoption and use in the Canadian post-secondary institutions. Please join me in welcoming Mr. Michael Burt, Vice President of the Conference Board of Canada.
Thank you. Thank you, everybody. So, very quickly, again, my name is Michael Burt, I'm Vice President of the Conference Board of Canada. For those of you who don't know the Conference Board, we're a nonprofit research institute. We're based virtually. We have people right across the country. We're a virtual first organization. And we do research and convening in 8 different areas, including economics, education, healthcare, Indigenous Northern communities, innovation, sustainability, healthcare, and human capital. I think I got all of them. Part of my role at the Conference Board is overseeing both our education and our economics teams. I'm an economist by training, that's my background. And I'm also the executive lead for our partnership we have with Toronto Metropolitan University called the Future Skills Centre, which is a federal government-funded initiative focused on the future of work. It's a multi-year initiative. We've been up and running for about 6 or 7 years now, and we continue to do work in this space. What I'd like to talk to you a bit about today is our work on basically how AI could potentially impact the workforce. And it's really going to draw from a few different pieces, some of our work in the FSC space, and also some work that we've done with the government of Alberta here in Alberta, and our partners at Amii. They helped us to do some of the data collection for this, some of the work that we're going to be talking about today. So, the question I always get when I talk to audiences about the workforce implications of AI is AI here to take your job? I would say the answer is no. That's not really the case, despite some of the headlines that we're showing you here. But that said, it is a potential game changer. When we talk about automation, and we've done a lot of work on automation impacts on the workforce over the last decade or so, almost all of our work up until a few years ago was very much focused on the automation of physical tasks. AI is quite different because it allows for the automation of cognitive tasks. So this is a whole new area of automation, and it means that it has implications for jobs that traditionally have not necessarily been an area of concern when you're talking about automation impacts. In fact, in our work that we've done, we've looked at 8 different technology clusters to try and understand what the impacts of technology will be on the nature of work in Canada. And AI pretty much pops out at the top in terms of the breadth and depth of the potential impacts on the workforce. Now, I probably already said the word potential 10 times in this presentation, and it's really a critical word because one of the things that these headlines often miss is when you dig into these studies looking at the impact of automation or AI on the workforce, it's very critical that they say this is based on adoption curves and assumptions around how these technologies will impact the workforce. I mean, ultimately, it's about changing what we do as opposed to eliminating jobs. When you talk about any technology, certainly some roles may be more impacted than others, but really what you're talking about is different tools you're using, different processes, different tasks that you're undertaking, and that's really what the impact is about. So when we talk about the impact of automation or AI, and specifically on the workforce, there's really 3 critical pillars you need to understand. First and foremost is task exposure, and that gets to what I was just saying. So when what we've done is gone into actually patent filing data and look at what skills are listed in the patent filings to try and map that onto the different tasks that people do in their jobs on a day-to-day basis. And that is what informs our understanding of how different technologies will impact the tasks or the nature of work for different roles across the country and here in Alberta. The second big pillar is, okay, these technologies have the impact or the potential to impact a particular task. How will it impact that task? So we translate that into productivity impacts. Productivity, very fancy word, which is basically means what's the value of what you produce in an hour of time, right? And so we try to measure how technology adoption will increase the ability of people to produce more value in a unit of time, an hour of time. And then the last big pillar you have to understand is business adoption. You can have the best technology in the world, it can be the most impactful thing you'd ever heard of, but if nobody ever implements it, it will have zero impact. And so this is really a critical thing when you talk about any adoption curve. How long will it take? How quickly? What's the penetration? All of these things. And so I just want to quickly, over the next few minutes, walk you through each of these three pillars to help you understand the impact for for AI specifically. So this chart, sorry, I know it's a little busy, it's a box and whisker chart, but it looks at the 8 different technology clusters that we examine in our work. And AI really pops out for a couple of reasons here. Firstly, if you look at the mean, the bar, across all of these different technologies, AI really stands out where it has the highest average impact across jobs of most of these technologies. And I mean, AVs and robotics are similar in terms of their average potential impact, but the distribution is much smaller, which means there's going to be a significant impact for a lot of roles. There's not going to be very many roles that aren't impacted at all. And some roles, if you look at the outliers here, so the ones at the top, you're going to have some roles where 50% or more of what they do are impacted as a result of AI. So to help you understand when we talk about tasks and skills, some of the things that pop out in our analysis around how AI will impact what we do: analysis, evaluation, monitoring, problem solving, critical thinking, numeracy. These are as I said, cognitive tasks that traditionally have not been the domain of automation, discussion around automation, and this is why AI is really quite a game changer. When you talk about roles specifically potentially impacted by AI, as I said, pretty much everything can potentially be impacted, so I had to try and find a way to focus the analysis a little bit. What we're doing here is saying these are jobs where 20% or more of what they do are likely to be impacted by AI, if you look at their job from a task perspective. And it really falls into 2 broad clusters here. First, we've got professional roles, right? So these are your data scientists, your software engineers, data entry, records management, business systems analysts, a whole variety of roles. A lot of these are professional roles. Again, if you talked to me 5 years ago about automation impacts, none of these would have been on the list because these are cognitive tasks that are being automated. The other big bucket here, and it might be a bit of a surprise to folks, are skilled trades. Now, these are roles that are more traditionally impacted by automation technologies, so dispatchers, millwrights, mechanics, machinery operators. But how AI potentially will impact these roles is through the tools and technologies that they use, because AI will be embedded in them. Another way we can look at how AI will impact the nature of work is by sector. And so what I've done is translate these skill and task requirements back to major sectors in the economy. And essentially what you're seeing with the bar chart here is for pretty much every major sector of the economy, 10% or more of the tasks that are undertaken in that sector could be impacted by AI, okay? This is really unusual. None of the other technologies that we look at do you see this breadth of impact. It's quite often you'll see a particular, like AVs has a big impact, for example, on transportation. It'll have a bigger impact than AI. But to see this where every single sector has a large and significant impact is very unusual, and it really does get into that breadth and depth that we talk about when we talk about AI impacts. The other thing I'll probably say here is just quickly, AI is the single biggest technology implications for 8 of the 20 major sectors that I'm listing here. So it is the biggest thing for a number of these sectors, in particular service sectors. And then the other thing I'll just point out is if you look at the top of the list, it's transportation, mining, oil and gas, utilities, construction. It may be a bit of a surprise to folks, but because again, these are your goods producing industries, the ones that are more susceptible to traditional automation technologies. And but again, this is about transforming how people use tools and technologies in those industries. So the second pillar that I laid out is the productivity pillar, when you're trying to understand how technology will impact work, or AI will impact work. Our Bank of Canada, last year, one of the governors there announced that Canada has a productivity emergency. Break the glass, we need to do something about this. Well, what's going on with that? As I said, productivity really just measures how much value a person produces in an hour of work. Fairly simple concept. How is it impact, or how do we adjust that? What influences productivity? It's really three key things. Firstly, the availability of tools and technologies. So, it's the shovel versus a backhoe. You can do a lot more with a backhoe than you can with a shovel. Second thing is how well you use that technology. So if you got a backhoe but you only use it an hour out of the day, that's not necessarily the best use of that technology. And the last thing is around the skills and abilities of workers. So can workers do they actually know how to use that tool? Can they use the backhoe, or does it sit there not used because nobody knows how to do anything with it? Why did the Bank of Canada say we have a productivity emergency? Canada's productivity performance has been, frankly, not great for the last 20, 30 years. We've been gradually falling behind our peers in the OECD. In fact, Canada now is below average in the OECD in terms of our output per hour, or value of our output per hour. And the reason why this has been kind of a slow motion crisis in development, the reason why the Bank of Canada made that statement is because we've gotten to a point now where productivity in Canada has been at a standstill. It's not been slow growth, it's been no growth. We produce as much per hour worked today in Canada as we did 7 years ago. So all of you can think about what you were doing 7 years ago. Hopefully you're doing something more valuable today than you were back then. So that's why the Bank of Canada talked about this as an emergency, as a crisis. And this is important in the context of AI because basically, because AI can impact so many roles, so many sectors, it can have a huge impact on our productivity performance. And that's what this next chart is showing, is the potential productivity impact of AI across different sectors in the Canadian economy. And as you can see, on average, you're talking about 8 to 10% increase in productivity. And that's based off the AI technology that's available today, right now. Our analysis was based off of patent filings that were available as of 2024. So as the technology continues to evolve, we are likely to see even bigger productivity impacts or potential impacts. The other thing I guess I'll just say here is that AI is the biggest single productivity enhancing technology among the 8 clusters that we looked at. In fact, we think if AI was totally or fully implemented with the current technology that's available, would add about $200 billion to Canadian GDP today, right? So that's about a 10% increase in GDP today from what it is right now. But of course, in order for these productivity gains to be realized, we need that third pillar to happen. We need adoption. So Canada's, our performance on technology adoption there's a fairly standard pattern. We're generally pretty good at early stage innovation, and certainly this is true for AI. We're well regarded in our AI research. We've made investments in organizations like Amii to try and get AI integrated and active in our organizations. But we tend to fall down in the later stages of the innovation journey. So we don't do so well at commercialization. We don't do so well at adoption. We're not yet there at that stage for AI. I'm just showing you, this is one study from IBM. There's lots of different surveys out there to try and understand what adoption looks like across countries. You get different results depending on who you're talking to, size of organization, whether they're multinationals or not. I just brought this as an example, but you see this fairly consistently, where if you look at the OECD countries, Canada's kind of middle of the pack. Some of them are ahead of us, some of them are behind us, depends on the survey. But ultimately, we're still in the game, if you will, in terms of adoption for AI. But given our I'll call it national history for AI adoption, or sorry, for technology adoption, we do have concerns that we may start to fall behind some of our peers, which would not allow these productivity gains and benefits to ultimately materialize. So one of the ways that we are measuring adoption of AI in Canada right now is through a data set we recently acquired. It's basically a database of web scrape job postings data going back to 2018. It allows us to really look at what employers are looking for in their job postings. We have millions of job postings. We're able to scan through it using actually some machine learning and AI algorithms to get an understanding of what's actually going on in terms of employer demand for different skills, tools, technologies. And so with that, we've built out a cluster of AI skills that employers are commonly looking for, and we've been able to track that over time. So in the last 6-7 years, we've seen roughly a tripling of job postings that have some form of AI skills required in them. So that's a big increase over a fairly short period of time. 1% of job postings in Canada now explicitly ask for some form of AI skills. Not a huge share just yet, but it's growing. To put that into perspective, most technologies have less than, aside from like productivity tools like Office, very few technologies have more than 5% of the job postings explicitly requiring it or looking for it, so that this is not that unusual, but we still do continue to see some growth here. The other thing that's really interesting here when we're talking about adoption of AI is when you look at the types of roles that require AI skills. The first big group is basically the data folks, the modelers, the one building the models, the ones using the models, very much in-demand AI skills for folks in that space. The second big group is educators. So these are people teaching others about AI, whether in the post-secondary sector or inside the organizations. And then the third big group are what we call translators. And these are really, really important when we talk about AI adoption. An example would be somebody like myself. I understand enough about AI to understand use cases in my organization, to have be able to scan what tools are out there, how I might apply them to my organization. I'm senior enough in my organization to actually be able to get resources behind the implementation and deployment of that, make sure we have internal processes and whatnot in place. But I'm not an AI expert. I don't build models. And so these roles are really critical to adoption in our organizations across the country, because without them, we're not going to see those adoption numbers continue to rise. Oops. So just before I wrap up here, I thought I'd return back to my initial slide saying, will AI take your job, right? Again, I hear this question all the time. If people are worried about that, I think a big thing we need to do is talk about worker resilience. How do we prepare people for a world where technology continues to change, skills continue to change? And so we do a lot of work with the post-secondary sector talking about these sorts of things. And so these are just some of the findings from our research in this space. But basically, first of all, it's about how we deliver skills, right? So if I'm mid-career, I have a mortgage, I have family, whatever, it's very hard for me financially to take a step away from work to go back and do a 4-year degree or some other multi-year formal education. And so a lot of this is around how do we build our new models in our education system that allow for skills acquisition in a much more timely and targeted way. So rather than a 4-year diploma that covers a whole variety of skills, what's the one skill I need for the particular role that I'm working in, and can I get it in a few months or even a few weeks rather than a few years? Next big thing is around fostering lifelong learning. This is really important. Canada tends to be kind of middle of the pack globally around our investments in continuing education. Our employers don't spend a lot compared to our global peers in terms of upgrading the skills of their people, so making sure we're continuing to invest in our people. Third big thing was around credentials recognition. So outside of the tech space, micro-credentials are not commonly recognized by employers, so helping to understand why is that, how do we improve on that. Part of it's about shifting a model away from do you have a degree to what I need are skills in A, B, C, and D, and getting employers to focus on that as a way to assess the performance of their staff and when they're hiring the capabilities of people. And then the last big thing I'll say is if individuals are worrying about what skills I should develop to improve my resiliency, a lot of them are the traditional people skills or soft skills. We call them social and emotional skills in our work. But just listing out a few of them here: critical thinking, active listening, problem solving, social perceptiveness. These are the things that are difficult to automate. They're in high demand. They're in high demand across most roles. And so ultimately, when we talk to employers, these are the skills that are hard to train for, right? So it's hard for me to train somebody to have good judgment, but I can train somebody on a software package if I need to, right? And so the technical skills are relatively easier to train for. And so these are the skills we often talk about people needing to develop if they want to have resilience long-term in the labor market. So just to close out, basically we're in the world now where we have many employers now actively deploying AI. And of course, those surveys don't include, I would call, passive deployments in AI that's embedded in productivity tools like Office that we all use on a day-to-day basis. This adoption means that we're likely to see continuing impacts on a wide variety of roles. As I said, AI, the breadth and depth of the potential impacts of AI on the workforce is really unparalleled when you look at different types of automation technologies. Again, I'll just highlight the word potential. These things, I don't want to be up here saying we're going to see 10% of the workforce disappear or something like that. This is about how quickly businesses adopt, how they adopt it. But I do think we will see significant changes in the nature of work. People will be doing things differently. They'll be doing them with different tools than they've been doing them historically, and that's where the big impacts will come from AI. And in order to make that happen, we need time. We need businesses and organizations to invest in these tools, and we need AI literacy. Very, very important. Whenever we talk to stakeholders in this space, from the CEO suite down to the frontline workers, helping them understand how you can use AI, what are the tools that are out there, how can it be applied to my role, what are the risks, how do you mitigate those risks, that's critical if we're going to see increased adoption and uptake. So here's just a few of the reports that I've drawn from in my comments. These are all on our website. Happy to talk to anybody about these. And yeah, I think we've got about 5 minutes left for questions if anyone has any questions.
Thank you for your presentation. I have a question about the translator the position that you talk about, because for AI adoption, you mentioned that this is an important position to have in your company. So I want to know that how we can train the senior manager about AI. What's the requirement, and how we can engage them and motivate them to be part of this training?
It's a good question. I think, first of all, you need to have buy-in from the top that this is a worthwhile thing. It's very hard to convince somebody that you should do this if they don't believe it, right? So I think you need to have that initial buy-in. Once you've got that buy-in, I do think there are, organizations like Amii and others out there that do have training programs to try and help improve AI literacy. I find a lot of organizations we work with, you often have an internal champion, right? So somebody who is senior enough to have influence and knowledgeable enough to start building those connections and saying, okay, here's training programs you should be aware of, or here's tools or technologies you should be aware of. But I think you need that buy-in from the top. You probably need internal champions, and then most organizations don't have the resources to build something for themselves, I think, but there's lots of off-the-shelf things out there that I think people can leverage to kind of build that literacy.
Yeah, thank you. But I want to know that whether we need to have a customized training for those translators, or just foundational training that, like something that Amii offering, is good enough to do so?
Yeah. I think probably what I would advise with that is just be deliberate in creating those translators. So they're your champions, right? And so if you don't have internal champions, I would say like that's what you need to. That's the first step, is building those champions, and those are your integrators. So, yeah.
Hi, Michael.
Hi.
Thank you for the presentation. I got a question. You talked about the productivity emergency over the last 30 years, and I'm in education, but K to 12. Mm-hmm. And if I look at how we've adopted technology, for the most part in schooling, it directly links to that emergency and the lack of capacity and skill, but we still only kind of look at it from university reskilling of the workforce instead of really looking at it from early childhood to grade 12. What do we need to do to make sure that they're ready for that type of training, and that so they're ready for their workforce and their civic life? So areas like the Netherlands have invested 140 million euro into looking at this, with Noli and Learnovate in Ireland have invested, quite a lot of sum as well, though I think it's over 50 million. We haven't really invested in trying to redefine the profession and redefine what pedagogical practices and assessment need to come into play to be able to integrate AI and integrate the digital tools. I'm wondering what your thoughts are on that, and is there a gap there that we're not addressing that will just repeat this constantly and we'll never actually catch up?
So it's another good question. Now, we actually have a project we're kicking off with the Future Skills Center probably later, well, it will be later this year, but looking at the K-12 space and this question in particular. But so I don't have any findings to share with you yet. But broadly, I would say it is. I think AI's the ability to at least understand the basics of it in terms of how you can use it and what the risks and concerns are, how do you mitigate them, I think is fundamental. I think it's going to be like 5 or 10 years from now, just like you need to know how to use the internet, right? Like I think it's going to be a fundamental skill that's required in almost anything we do. So being deliberate about building that into our primary and secondary education system, I think is important. It's one of those fundamental building blocks, like reading and writing, that we will probably need to incorporate. But to your point, I'm not aware of any jurisdictions in Canada right now that are doing that right now. So
there is none, I can tell you. Thank you.
Thanks.
Thank you for your presentation. I thought it was very insightful. From an HR perspective, I've learned a lot about AI and all of the AI literacy. One of the things that you talked about was those micro-credentials and having employers to focus on those micro-credentials. What would you say? So I'm an employer. I employ lots of youth. What kind of micro-credentials should we be looking at for the future of our workforce? Now, I mean, everything is different, but I'd be curious to say, what would you say to an employer? Because I am one.
Yeah. Okay. So it obviously very much depends on who you are as an employer, but when I mentioned micro-credentials, there's a couple of things. So number one, we work with a couple purveyors of micro-credentials, and we use our data to try and inform the models that present the if I'm in profession X, here's the courses you should take to improve your skills, right? So I think that's the first step. Part of that is around, the reason I bring it up is because we know from our own research that outside of a few sectors, particularly the tech sector, recognition of micro-credentials is very low. And they're not necessarily, I have a badge saying I can do X, it's just not widely recognized among most employers. So I think there's a journey around how do we get employers to recognize that more. In terms of what should you do, probably what I would say, and these are skills that are hard to develop, but I would go back to those resiliency skills that I talked about. These are skills that are, at least if you believe our research and our modeling and our analysis, these are skills that are in high demand, will continue to be in high demand, and they're highly transferable across roles. So it doesn't matter kind of what industry you're in, what job you have, they're valuable. So that probably would be what I'd focus on. So.
Perfect. Thank you.
Thanks.
Right. Thank you very much for your presentation. So I was wondering about the other productivity enhancements that we can do. It's been a problem for 7 years, and AI wasn't there 7 years ago. And what is the multiplying effect that AI would have in those lower hanging fruit?
Yeah. So, I mean, there's a lot of reasons why productivity hasn't improved in the last 7 years. A lot of it's about the mix of the type of work we're doing in the country and that sort of thing. But I mean, even within specific roles and sectors, like construction is a perfect example. Productivity in construction's fallen by about 10% over that period of time, right? And what that's about is the traditional explanation for it is basically you're seeing a shift in you've got a lot of older, highly skilled workers who are kind of transitioning out of the sector. Newer ones are coming in, but they don't have the same level of productivity as the ones who are leaving, right? Because they're not as mature in their knowledge base. So, I mean, solving the productivity problem, I think part of it is around us as a society thinking very deliberately about how we best make use of the people we have, right? So choosing to invest in job creation for roles that are high productivity, that create a lot of value. Part of it is around that adoption challenge we have in Canada that I referenced. Like technology adoption, we are generally years behind our OECD peers. Pick your technology. That's just the general truth of the fact. I mean, AI, we're doing pretty good so far, but I do worry that's a pattern we may slip into again. So AI is not going to be a panacea. It's not going to solve all the problems. I just highlighted it as the clusters we looked at, so the 8 clusters we looked at, it's the one that has the potential biggest impact, both in terms of absolute value, the 200 billion that I mentioned, but also most of those technologies only benefit a handful of sectors, whereas AI has a benefit across all sectors, and so it's the most ubiquitous, or one that has the biggest impact across sectors. So.
Thank you.
On your productivity gain slide, beyond transportation, you have the next 5 are kind of heavy industries,
yep.
Mining, agriculture. Where are you seeing the biggest potential gains in those particular industries, and where are the last question, where are the low-hanging fruit for productivity gains in some of the heavy industries?
I wish I had one of my researchers here who are more familiar with the specific technologies in those clusters, but what I would say is a lot of it boils down to how people use the tools and the tools that are available to them, right? So the AI is going to be embedded in, if you're I don't know, I'm trying to think of an example, but a dispatcher, right? Where it's you're not having to manually map, this person should be doing this and I should assign this person to this. It's the AI will assist with those job allocations, so it's much more of an oversight role rather than you're in the weeds of actually assigning people certain tasks, right? So but it's really around the AI being embedded in the tools that people are using in those roles or in those sectors. So.
Thank you.
Yep. Well, thanks everyone. I'm over time. I appreciate your questions, and I hope you enjoyed it. Thank you, everyone.
So, hi everyone. My name is Bruce Alton. I'm CEO and co-founder of Robim Technologies, and I'm here today to talk about construction, robotics, and artificial intelligence. I'm going to talk about what's going on in the space. I'm a non-technical person, so I'm going to talk about some of the business aspects that are happening, what's going on today, why now, and then also some challenges that we're facing as a company. Our company, Robim, is at the intersection of construction, robotics, and AI. And I want to get to the point early that if we can't actually develop technologies that people can actually utilize in industry, they're probably not worthwhile developing. So I really want to focus on how we can actually implement artificial intelligence technologies. Before we start, though, I want to talk about a couple of my favorite buildings that I have in the world. This first one is called the Göbekli Tepe. It's a structure that's in Turkey. They just discovered it about 30 years ago. And if you look at the drawing or look at the photo, it's really remarkable. You've got some curved brick walls, you've got some smooth columns. It was quite a substantial structure. And this is known as the oldest building in the world, the oldest constructed building in the world. It's about 12,000 years old. It was built in 10,000 BC. And I think it's just remarkable that long ago they built a building of that type. This is called the Haruji Temple. It's in Nara, Japan. It's just outside of Osaka. And it was built in 607 AD. It was built about 1,400 years ago. And it's known as the world's oldest wood structure overall. And when I see these images, it really makes me realize that construction's probably the oldest industry in the world. If we needed to live somewhere, we needed to work somewhere, we need to do something in society, we generally had to build something, to build a structure to accommodate that. So I think it's remarkable that we have this industry today, though obviously still with us, but it's the oldest industry in the world. And it's also the largest industry in the world. If you look at the stats, McKinsey's done a bunch of studies in the construction space. It's about a $13 trillion industry globally. It's about 13% of the global GDP. It employs about 8% of the people in the world. Here in Alberta, it's a $30 billion industry. It employs about 250,000 Albertans, and it's the third largest industry here. So massive, massive industry in the world. And now, of course, we're here at Upper Bound, the Amii. We're here to talk about artificial intelligence, and that's why everyone is here. And I would argue that artificial intelligence is probably the newest industry in the world. It's relatively new. I mean, the technologies have been around for a number of decades, but really it's just been in the last 10 or 15 years that we're starting to see the commercial applications of AI and how it's been creating value in the business world. And I think we could also argue that artificial intelligence is probably the fastest growing industry in the world as well. I mean, you have conferences like this that even a few years ago didn't even exist. And now today, we've just got thousands of people that are at this conference alone. But perhaps more importantly, this artificial intelligence industry is one that is growing very, very quickly in the sense that 10 years ago, it was only a single double-digit billion-dollar industry. Today, it's a $600, $700 billion industry, depending on how you measure it. So it's grown about 30 times from a business perspective. And if we go forward, it's going to grow just as much. Maybe not quite the same rate, but it's going to be a multi-trillion-dollar industry, maybe 10 or 15 times the size today in, say, 10 years or so. But more importantly, again, the reason why everyone's here, this represents a once-in-a-generation opportunity to take advantage of a disruptive technology that's going to impact pretty much everything that we do in our society. So really exciting times. So one quick thing, though, about comparing the construction industry and the artificial intelligence industry, construction just dwarfs it. Construction is probably 30 times the size of the artificial intelligence industry. It is absolutely massive and much, much larger than the artificial intelligence industry. And even if AI grows, triples or quadruples, or it goes 10x in size, it's still going to be a small portion or small percentage of what the construction industry is. So I'm really trying to emphasize the point here that we really should pay attention to construction. It's an industry that is going to have an intersection with AI, and that's really what I want to talk about today. What is the intersection of AI, construction, the world's fastest and newest industry, with the construction industry that's one of the oldest and largest industries in the world? But before we do that, since we're at an AI conference, I'm not going to talk a lot about the AI technologies. I'm assuming you're going to have a better understanding of the technologies than I do. But I do want to talk a bit about the construction industry. And this got some really unique characteristics that we should really be paying attention to. So this may be a slight exaggeration, but this is how I feel the construction is today. I spent 10 years as the chief operating officer of a real estate development company, and we built a number of buildings. And I have a background in technology, but I was really frustrated why the construction industry was not utilizing new technologies in terms of advancing the industry as compared to many other industries. So how we built, this is a barn raising, but how we build a single family house, how we build a multifamily residential unit, if you go see a construction site, it's not that much different compared to 50 or 60 years ago. Still very traditional industry, highly dependent on human labor. But we can understand why it's actually not advancing a lot in terms of technologies. And there's a few characteristics we should be aware of. Number one, when we say construction, in quotation marks, it's like saying artificial intelligence. It's an umbrella term that encompasses a number of different areas. We've got commercial construction, you've got institutional construction, you've got industrial construction, residential, all the way through. There's all these different areas of types of construction. And then it's kind of hard to see, but all these boxes represent the different aspects of a typical construction process. So on the far left-hand side, you've got an owner, a developer, someone who wants to design and build a building. They have to hire an architect and engineer, and then the engineers have to design and do all the drawings, stamp these drawings from which the building would be built. Then there's an estimating process where you have to figure out what's the cost to build this building. There's a bidding process, and then they award a contract to a general contractor. But the general contractor doesn't actually build anything. Very few general contractors build things. What they typically do is organize a bunch of trades and a bunch of sub-trades. So these are the people who do the actual building. And then finally, we start constructing the building. And then when it's done, we hand it over to the owner, and it's maintained and operated, and it has to last for 20, 50, 100 years in the future. So very, very complex sort of industry, lots of handoffs, lots of friction into the process. So the industry, if you kind of want to summarize it overall, it does have a number of unique characteristics. There's a bunch of different players involved, in all those different segments and the different types of construction, the different aspects of construction. It's highly fragmented, so it's very, very competitive. The barriers to entry are quite low. So you have really inability for people to gather scale in the industry. The industry really does not promote collaboration. So all those individual boxes represent a handover point, but all those people within that box are trying to protect their profit pools. They don't want anyone else to benefit from what they're doing. So that causes delay and friction. And also in construction, pretty much every single construction project is unique. So even if you're a housing developer and you're developing 100 houses of the exact same design in a subdivision, they're all unique projects. There's always a site condition or likely a customization that's needed, just makes it slightly different. So it's not really conducive to, for example, robotic fabrication. And finally, it's a low volume industry. So even if there's probably at any given time here in Edmonton, there's probably 1,000 houses under construction, tens of thousands of houses under construction in any given area over a course of a few years. But those volumes are relatively low. So if you think about traditional manufacturing and industries that are automated, they can make an investment into fabricating something, doing the same thing over and over again at high volumes. Construction's not like that. Compared to traditional manufacturing, the volumes are quite low. So what happens is these are creating barriers to an innovation, and they also create barriers in terms of adopting new technologies. It's not like the construction industry, there's a bunch of dumb people there. That's absolutely not the case. It's just actually very, very hard in adopting new technologies and standardizing. So you kind of end up with this really interesting dichotomy. You've got on one hand, you've got this industry that when you think about it, I think we don't actually give it enough credit. It is absolutely crucial for a high quality of life in the world. If we want to bring the developing world into the developed world, we need housing, we need healthcare, we need educational facilities. If we want to improve the quality of life here in Edmonton or anywhere else in the world, we need construction services. We need the ability to build these facilities that we can take advantage of. And this industry is really growing. So you think about urbanization, like the global mega trends, people are moving to cities. You think about climate resilience and climate change, we have to change our infrastructure, the energy transition to a low carbon environment, and even aging demographics. We are aging out as a society. Our populations are going to fall around the world. So how do we deal with that? We need new facilities, new infrastructure. We need construction services to do that. And so as we build all those new things moving forward, it's a great industry to be in from that perspective. The demand is there, but there's a kind of a dark side of the construction industry as well. So the industry, and I'll show you some stats to back this up, but it suffers incredibly lagging productivity. There's huge labor shortages. If you know anyone in the construction industry now, they're probably complaining about the lack of labor to get on their construction sites. And generally, and I won't talk about all the stats, but if you just do a quick Google search, you'll find out that construction projects are typically late and they're typically over budget. I think the stats are 80% of large major construction projects, according to Kinsey, are late, and they're on average 20% over budget. So really the result of this is it's creating this massive infrastructure gap. And so I was aware of this gap. So like in Canada, for example, we're short 3 million homes. And we actually have the money to do that, to build those homes, but we don't have the capacity in the construction industry to actually fill that gap. So that's a big problem. And I think this chart says it all. So this was published in The Economist. It's some McKinsey data. And basically what it shows is productivity growth of different industries for the last 75 years. So you can see from a starting point in 1947, for every hour of work in a particular industry, we've seen how more productive those industries are. So if you look at the top one, agriculture, it's 16 times more productive than it was back in 1947. Manufacturing, 8x, all industries overall about 4x, but look at construction, the red line on the bottom, 0 productivity growth over the last 75 years. It's crazy. And if you kind of look back for the last 40 years, maybe since 1980, it's actually been negative. So we're actually getting worse at construction over the last many years. And if you kind of break that down into some different areas, when you kind of look at all other industries, why have they advanced? Why have they become more productive? Well, one of the key reasons why is because of robotics and automation. I mean, I'm oversimplifying this, but that's really the key reasons why. We've been able to automate processes, and we're also able to instill some element of robotics, automatic fabrication or production within those industries. That's really the essence why those industries have been more productive. So the next natural question to ask is, why not construction? Why hasn't construction been able to adapt these new technologies? And it's because of the reasons I said before. There's a lot of issues that make the industry not really, they don't adopt technologies very well. It's very fragmented and segmented. There's actually a lot of new regulations, which are good things in the sense the work sites are much safer than they were, several decades ago. But we have low volumes. There's this need for customization. So it just is problematic in terms of adopting new technologies. So the question you may be asking or wondering about, why am I up here? What's changed? Well, what's changed is AI. So we're at an AI conference, and if we start looking at a lot of the technical discussions of what's going on, you're starting to see how some of these applications might be applied to the construction industry. And as it turns out, we're at an inflection point. There are a number of things that we're seeing in our area, but also related to a number of other construction companies, where AI is going to be able to automate design. It's going to be able to do much more predictive real-time scheduling and planning. Work sites will be much safer because of AI-driven systems. Costs and waste will go down. Quality is going to go up. And also, perhaps more importantly, and one thing they're really focused on in our company, is AI-driven robots. So how can we make robotics much more intelligent so they can fabricate things on a construction site? So that's really what we want to focus on today. So what I'm going to do is I'm not going to talk about AI technologies, but I'm going to talk about the application of AI. I'm going to give you real-life examples of companies that I've met that are using AI in the construction space. And then I'm going to talk about the challenges. So I've spent most of my career in new business ventures, new business development, product development. And again, if we don't develop technologies that people actually use in industry, why are we developing them? They won't create any value. So I want to talk about that and some of the challenges that if you're interested in this space and you want to develop technologies or you're a technologist, here's some things you've got to keep in mind and some things that we're doing, a framework that we're using that you might find useful. And finally, I'm going to end off the talk by talking about some of the very specific opportunities here in Edmonton and Alberta related to construction, engineering, and AI. So let's dig in. So as I talked about, I want to talk about just the applications of AI. I'm going to assuming that most people know what these areas are. I mean, we're talking about machine learning and augmented reality, computer vision, NLP, et cetera, et cetera, et cetera. But really, I'm more interested in how are they applied to the industry. So I'll refer back to these boxes, and we can start categorizing AI into these different areas. And there's actually 6 different areas I'm going to talk about and give you very specific examples. So the design and planning stage, that left-hand side of the boxes, the project costing and scheduling, operating efficiency, monitoring, inspection, training and safety, and then finally robotics and automation. So here's some companies that I've talked to in the last year or so who are using AI technology. So the first one I want to talk about, this is probably a year old, so it's a bit dated now, but Stantec is starting to use AI technologies in their design process. So if you can see the video in the corner, basically what they're doing, one of their architects actually just did this himself, where he's starting to sketch on an iPad and the Stable Diffusion's automatically generating the images. I mean, we're starting to do this with ChatGPT and Gemini and everything else. But it was a year ago, this was actually very difficult to do. And it just gives they're not going to disclose to me the details of what they're doing, but they're starting to use these very basic tools for their design process and eventually into their engineering processes. And this is just kind of a first example of how they're setting that up. PCL. I was talking to Brian Gu, who's the AI guy at PCL recently, and he was telling me about this product they've launched to use internally. It's called Beeline. And so PCL is the largest general contractor in Canada. I think they're like a $10 billion company. And if you think of a building like this or a big industrial facility, you've got all the cabling, you've got all the wiring, the fiber optic cables, the electrical wiring and everything else. There could be literally miles and miles or kilometers and kilometers of these different cabling you've got to route through the building. It's a huge planning challenge, and up till recently, a lot of it was done manually. And it can cause, and I've heard of cases in some of the projects I've been involved in, this single factor of how to actually plan out the raceways for all this cabling actually can delay a project by many, many months. So they're developing AI tools to automate this entire process. So they think they're developing it internally, but it could make it available to their customers. On the project costing and scheduling side, there's a company called sketchdeck.ai. They're really focused on structural drawings, and the structural elements of a building, so the steel that's used in the building. And what they do is they're able to scan these drawings. I'm going to oversimplify it, but using computer vision and machine learning, they can automatically count up all the elements of steel and then generate the automated material takeoffs and bill of materials. So pretty seamless process. They can make an estimator about 2 to 4 times more efficient in using their tools. And if you've ever estimated a project or actually looked at these drawings, it's really remarkable that up until recently, people literally went through page by page, manually totaled all the different types of materials, put it in a spreadsheet, costed it out. It's just prone for making mistakes, and it's a very manual, mundane process. Turnover, because of that, is very, very high in the estimating world. So they can automate that whole process. There's another company called XKey AI Estimation. They do the same thing, but for electrical drawings. So again, you got to count all the individual light switches and receptacles and all the lights, etc. Total that up in a drawing in order to bid on the contract. So they're using computer vision to do this automatically, save a tremendous amount of time, and reduce the number of inefficiencies in this whole process. Pursuit Zen, they're using your past RFPs to help develop new RFPs. So they're kind of developing a large language model with their existing RFPs you've already done. If everyone here has probably done an RFP or proposal, they could be pretty onerous. So why not use the past experience you have to do that? So they're using AI to actually generate the first draft of the new RFPs. And then Cultivating. So Cultivating, as I understand it, they're not developing the AI in-house. They're actually developing as a off-the-shelf tools. And so what they're using is machine vision to read the supplier quotes and the invoices, and they're matching them up with the purchase orders. It's the one area that causes a lot of mistakes and confusions and extra costs and time when you're trying to reconcile it. So a very simple example, but really high impact in terms of when the quotes, invoices, and purchase orders need to be matched together. On the operational efficiency and mitigation side of things, I was talking to a couple different people at PCL, and they were telling me in general, they had many, many examples. Some of they didn't want to share, but just overall, they're heavily involved in investing in AI tools. They use it for decision support. They generate so much data. They kind of use it as the needle and haystack sort of approach to find information. A big issue is to prevent issues before they occur. You've heard of this concept of a change order in the construction industry. A change order really means that someone messed up. They didn't actually reconcile, some information, some drawings, someone missed something. And it's a very, very costly and time-consuming process. So they want to be able to prevent these issues before they occur. I was talking to Mark Bryant, who's the CIO of PCL. They're investing in a whole bunch of different areas in their IT side of their business, trying to make the operations more efficient as well. One interesting one they were able to tell me about is they call it Traverse. And so that, the diagram on the right just represents all the information that's generated for a large construction project. And you think about all the CAD drawings and proposals and change orders and RFPs and building codes, all these different things. It's really easy to miss something. So they've developed this product called Traverse that identifies and manages those relationships and identifies discrepancies so they don't cause problems or prevents errors before they occur. On the monitoring, inspection, and quality control side of things, again, a lot of really interesting applications. AltaML, they have a kind of a venture studio model where they will work with companies that have applications. They provide some of their AI talent to develop it. They've got a number of different use cases on it. I think some of them are pretty early and a bit confidential, but they're using computer vision in terms of quality control and inspections, but also on the asset maintenance side of things, so they can monitor an asset's life over time by utilizing different technologies. Some really interesting use cases. Scope AR is not in the construction field per se, but they use augmented reality for training, but also they can use augmented reality for quality control and QA and inspections on a construction site. So as the lower image on the right, that could be the visualization, the 3D model, what it's supposed to look like, and they can compare that to the actual build. Is what being built does it match the actual model? So again, a great way of using AI, in this case, augmented reality. On the training and safety side, just a couple unique examples. This one I just found interesting. It's a company called Sensi Image Technology. So if you think of a a large construction site, you've got that tower crane, the crane up in the top of the building, and all it does, it just lifts things up and puts it up in the building. But it can be quite a distance between the two. So you have a walkie-talkie, people are communicating, but sometimes you can't see what's going on. And often on a construction site, language is a big issue. It's a big barrier. But the industry around the world has this global way of communicating through hand signals. So I don't know what they are, but go up, go down, stop, or whatever it is. That's what they kind of depend on. The crane operator sees the person on the ground, and they use these hand signals. So what this company is doing is they've got a camera in the hard hat, and it's actually watching the hands, and then it's based on what it sees in the hands, it's communicating that information in any different language up to the operator of the crane. Really interesting, unique capability, and it's a universal problem. It's kind of a small little niche, but it's something they're able to sell all around the world. Correct AI, full disclosure, this is a company I'm a co-founder of. Correct AI is developing safety, basically collision avoidance hardware for industrial work sites. So on the back of that industrial equipment, the big yellow iron you have in a work site, the danger zone is that blind spot behind the operator. So on a really active construction site, you've got a lot of big equipment, you've got a lot of humans. If they collide, the human's gonna die, or is going to get injured or is going to die. And I think in Alberta or Western Canada, a person dies every couple months. Like, it's an incredibly dangerous environment. So what Correct AI does is they use computer vision to identify objects in your blind spot. So today you have your car, it just beeps like a proximity sensor, but you don't know if it's a human or whatever it is in the blind spot. They can use computer vision, identify, obviously a human is a greater threat or danger level than a piece of or a pile of dirt that might be there. They communicate that, it's all processed in real time, communicate that to the operator of the cab. The company, we're about 5 years old, and we're selling on five continents around the world, a number of different sites, but all enabled because of AI. And so finally, the robotics and automation side of things. And this is the really exciting stuff that's going on. I first, reluctantly want to show you some of the things going on in the humanoid robotics space. Like, it's really, really remarkable. Some of these videos you've probably seen on social media. Or Sanctuary AI is based in Vancouver. And if you just look at what the robot can do, the fine precision, the agility of a robot to do certain tasks, it's really remarkable. And it's really just been in the last couple of years they've had these capabilities. Figure AI down in the valley, they did a deal with OpenAI. We don't have the audio here, but basically the human is conversing with the robot, asking the robot to do certain things, but also asking the robot to explain why he's doing those things in the lab. It's really, really remarkable. So it's like ChatGPT, but an audio version of it. And then everyone's seen the videos of Boston Dynamics. They've got those robo-dogs and all those different animals. But just the ability and the agility of the humanoid robots and what it can do is really, really remarkable. And this has really just happened in the last couple of years. And then last year, about a year ago, I gave a version of this talk, and I found this video was just released probably about a year ago, I think last June, and it was just Tesla's got its humanoid robots that Elon's been pushing. Really, pretty amazing agility, picking things up, can pick up eggs, pretty cool. Then last week, I don't know if you saw this, but this is the latest version of the Tesla Optimus robots. I mean, just look at this. Like, this is just unbelievable what these things can do now. With Elon, I don't know if you can actually believe what he does all the time, but even if it's half true, it's pretty remarkable. So when you see these videos and you kind of imagine they could move from dancing to working on a construction site, are we going to see humanoid robots into the construction industry? Is that what we're talking about? Is that the opportunity? And I'd actually say maybe. It's not going to happen right away. There's some really significant, not downsides, but shortcomings of a humanoid robots. One is that you see all these demos and videos, they're great, but they're always a flat surface, controlled environment. A construction site is outside, it's very uneven, things are happening in real time. So it's probably going to be at least a few years before humanoid robots find themselves on the construction site. And perhaps the biggest shortcoming of a humanoid robot is the payload. Their ability to pick something up is actually very small. They cannot pick up a lot of anything of significant weight. That's another problem in the construction industry. But the important thing to realize is we've seen the advances just really in the last 6 or 8 months Is this going to get 1,000 times better in the next 5 or 10 years? Yeah, it could be. I mean, it's the AI software probably will, because it's easy to iterate software. Hardware takes a bit longer, but yeah, there's probably some things going to be happening in this area. But really what I want to focus on is some more practical applications related to robotics. I want to talk about 2 companies. One of them is our company, and the other company is Promise Robotics. So Promise Robotics, big shout out to Reza Nazari, who started Landmark Homes and AccuBuilt. They've raised a whole bunch of money, and what they want to do, they're building a factory that with robots, they'll fabricate a house in a closed environment, and then they'll ship all those parts of that house to site where it's going to be assembled. So they've got a facility on the south side near Nisku. They're opening up a new one in Calgary. I think it may already be open, a 60,000 square foot facility. And as I understand it, their business model is to set up these house building factories all across Canada to really address the labor shortage issue. They are a real leader and pioneer in this space. I also want to give a shout out to Clark Builders and AltaFab. They're 2 companies that have, they're not doing robotics internally, but they realize this is the future. So we've been working with them to say, how can we utilize robotics on their work sites? And we've got a few use cases that we're working through with them. So that brings us to our company, RoBIM Technology. So RO stands for robotics, BIM stands for building information modeling. And what we're doing is building a modular robotic fabrication platform that we could use off-site or on-site for residential and commercial construction. So probably the best way to describe what we do is I'm going to show you 2 short videos. This first video is the simulation software that we've developed. So basically what we can do is that we can import a component from a digital design, a BIM model, into our software. So say called a wall panel for a house. We import it into our software and we can fabricate it in quotation marks in a simulated environment. So along the bottom, we can drag and drop all the different process steps. We can take all the materials that are on the right-hand side, and we can optimize the construction process in a virtual environment. Some of our AI and new technologies embedded in this. We have Jason Yang, who's one of my co-founders. His PhD thesis was an optimization algorithm. So we can embed a lot of new technologies into this software. Another co-founder, Tim Tai, his PhD thesis is using reinforcement learning in terms of how do you assign a task between a robot and a human. A bunch of different other areas that we're going to be implementing some new technologies in this space. So the power of this software is, it's an easy to use graphical user interface. It's been designed for the construction industry from the ground up, but what it does, it actually programs the robot. So once we've optimized it, it automatically generates the robotic programming codes, and we program the robot. So if you're familiar with the robotics industry, there's ABB robots, KUKA robots, Universal robots. They all have software that's similar to this, but it just programs that particular robot brand. We're robot agnostic. We'll program with any robot brand that we're integrated with. And we've designed this from the ground up from the construction industry perspective. My co-founders are undergrads, masters, and PhDs, all related to construction, automation, and robotics. So we've built this from the ground up for the construction industry. The second aspect of what we do is once we've done that optimized design, we actually are creating a digital environment of the physical world. So this is our facility in Nisku. We have a standard robot arm. This particular brand is a ABB robot. We're not designing robots. We don't want to take that risk. We want to just focus on the actually integrating off-the-shelf robots. And so you'll see on the end of the arm tool, there's these things called end effectors. The first one you saw was a pick and place tool, picks up a 2x4, places it. The second one is a nail gun, and this is a vacuum gripper, where it's picking up the plywood and putting it on the frame. So there's assembly jig there. These are all independent components that we have now 15 robotic capabilities. We'll have 26 by the end of this year. It's all part of our IP library. But with that, we're fabricating a wall frame, but we can actually fabricate a wide variety of products. So we've got one robotic fabrication module that can fabricate a wide variety of different products. So the challenge we have and the opportunity we have is what are we going to make with these things? So we're combining all the pieces together, and we're taking the simulation software, the assembly jigs, the end effectors, all these different end-of-arm tools. We think of the end-of-arm tools, they can move materials around, so like the pick and place and vacuum gripper. They could do some processing, so you're cutting, milling, routing, drilling. And the third category is fastening. So you have a nail gun, you have a screw gun, you have adhesives. You put all those together with those robotic capabilities, and we're creating this turnkey robotic fabrication system here in Edmonton. We call it a hive, and it's basically a module that has a number of common components. So we take all the different pieces, we put it together, it's backed up by our software, but the module can be reconfigured to do different types of construction. So you saw in the video, we can do wood stud construction. Well, we can also do light gauge steel stud construction you'd find in the construction industry. We're developing, we call them hives, we're developing a hive for exterior retrofit panels, we're developing a hive for material preparation and material cutting, and then finally, since it's modular, we can also make them expandable for higher volumes, but we're also making them modular so they can be mobile. We can put them in, say, a shipping container or in a trailer and take that trailer on site and actually do fabrication at the construction site. So anytime you need made-to-measure components, do that customization, we can do it on site. So when we kind of sell this to our customers, we're in the commercialization mode now. We're developing our capabilities. By this time next year, we'll have a product on the market. We've got 2 pilot projects, so we're generating revenue now in terms of what we're doing. But when we put it together, the value propositions or what we're selling to customers, it's an automated system, so it's robotic. It's multifunctional, so you have one robot that can do multiple different things, which helps in the ROI. It's turnkey, so we want to make it as easy as possible for companies to do robotic fabrication in their business, and also it's modular and mobile. And if we can do this, we can address the labor issues that the industry is facing. We can shorten schedules, we can reduce costs, and we can make it much easier to use. So these are really the key value propositions that we're proving out. So I've kind of summed that up in what we're doing. I also highlighted a number of different companies that are doing different things, give you actual examples of what they're doing in these areas. And I just scratched the surface. I wanted to give you some very specific examples. But if we actually kind of move forward, and I'm sure you'll see other technologies at this conference and elsewhere and online that are focused on the space, that's great. But when we kind of move forward and take a look at the really cool technologies, how are we actually going to succeed? How do we successfully implement AI? And this is really critical, because I've said twice already, if we can't actually create value for customers, why are we developing the technology in the first place? So one thing I just want to talk about is implementing AI and in the construction industry. And I'll be very honest that the technology is actually secondary. There's a lot of other factors we have to keep into place. So I reviewed the different characteristics of the construction industry, all the different things that are going on. You need to understand this. And the things I'm talking about today, even if you're in healthcare or you're in consumer goods or whatever it is, the concepts are the same here. You need to understand the industry within which that you're operating. So effectively what we need to do is that we kind of I'm oversimplifying this, but on one side we've got all the AI researchers, the technologists, on the other side you've got the industry. So we kind of want to look at this gap in the middle. How do we get that from the lab to the markets overall? And so it is quite complex. I spent a number of years in this space. We have to identify a problem we're going to solve. We have to validate that. We have to develop a whole bunch of MVPs, do a bunch of design and engineering. We've got to validate those. We've got to get into the market. We've got to improve that product over time. So really what you're doing is kind of making something very, very complex and making it very, very simple. Easier said than done. And so when I go through this process, and again, I'm going to overly simplify it, but we've identified 2 really significant challenges of getting the technology to the market. The first challenge and problem is the technology does not solve a customer problem. So it is better, faster, cheaper, but no one cares because no one has a need for that better, faster, cheaper. So what we really need to do is understand what problems can we solve first. RU problem first. So I've already highlighted a number of the challenges in the construction industry, the productivity, labor shortages, too expensive, takes too long, this infrastructure gap. What problem within that are you actually going to solve for? That's really, really critical. The number one reason why new products and new technologies fail is because they don't solve a problem. People spend all this time, money, and effort developing something that no one actually wants. And so I'm actually going to say if you're a technologist, if you don't address that, that's your fault. You are the reason why a product is going to fail. That may be kind of unfair thing to me to say, but it's absolutely true. I have talked to 3 or 4 people at this conference alone where they're developing some really cool technologies, but they don't have a clue how it's going to be applied. And I get very concerned for them in terms of if they want to commercialize it. So that's the problem on the technology side. I'm also the problem. So I'm the sales guy, I'm the CEO, I'm into the business development side of things. And so what we have a tendency to do is overpromise, underdeliver. We try to say, robots in construction is magic. It's going to do all these amazing things. And we can make a really compelling argument for that we can develop these incredible systems that are going to solve all the world's problems. And sometimes we can deliver these things, but it just takes too long. The customer's lost interest, or we've run out of money. So this is my problem. This is my fault that what we have to deal with. And so the advice I'm going to have with you today is, how do we bridge that gap? And so in a technology company, if you're an established business, the person who plays this role is the product manager. So the product manager, typically, they translate the customer need to the engineers, and then they translate what's possible for the engineers to the customers, and they figure it out, they do the translation in the middle. That's really what we need in construction robotics in the AI industry. So the challenge is, how do we bridge that gap between technology and the problem? And what we do need is we need some sort of translation tool. So we need to be able to have that. How can we translate some really complex technologies into the industry? How can they actually talk together with a common language? So we need a common language for researchers, entrepreneurs, and customers to actually figure out where these technologies can have application. We also need a filter. I mean, I'm not digging into a lot of the AI technologies that we have at Roban. There's just not enough time. But we do have limited resources. So how do we decide what to invest in? How do we develop a framework for that? And then finally, for it as a decision-making tool. In all those examples I showed you of all those companies, some of those technologies they're buying off the shelf. Sometimes they're partnering with another company, or if it's really critical, they're actually doing it internally. They want to own the IP. So this really helps with making as a decision-making tool. So really what it is, it's just a framework for integrating a technology with an industry. And not unlike in many companies, you have this technology stack, which is this strategic, integrated architecture. How do all the pieces fit together? That's really what we need in construction, AI, and robotics. So what I'm going to do is I'm going to very quickly go through what we've done at Robim, and this has proved to be really, really helpful for us as we have these conversations with our customers, with people at the university and other research institutions, and how do we decide what we're going to use. So our framework, our framework for AI, robotics, and technology, the bottom layer is pretty much everything here relates to data, right? But data is actually everywhere. So in the case of construction and AI, I showed you that simulation video. That was the simulation of a physical environment. So how do we gather that information, that physical environment, translate into a digital environment? Everything we build has to be based on engineer stamped drawings. You've got AutoCAD drawings, you've got cost spreadsheets. How do we import all that information to create a structured database? That's something that we can actually query. So that's the past data. Current data, we might need to do reality capture of this environment so we can actually build components in it. So it's maybe LiDAR, point cloud things. And then finally on the real-time data, if we want robots to be smarter and to make decisions in real time, we need to keep collecting data, real-time data, in order to program the robots. So then, once we have that data, a key element of that is the design. We only build from an engineered stamped drawing. So how do we translate that design into a plan that we can actually use? So what's the design intent? What is the intelligence we need to pull out of that design to come up with a series of individual tasks that allow us to build this project? So if we can identify the tasks, we can put them together into a workflow, and then once we have that workflow, we can simulate it. So we can simulate it. You saw the video that I showed on the screen. And then finally, we can fabricate it. Now, one of the really interesting things in robotics and construction, it's not going to be 100% robotics. It's actually going to be humans and robots working together. So how do we get them to work together? And then finally, how do we deploy this to the industry? This is less about the technology and more than dealing with the construction industry business models. How are we going to make money? How do we create value for them? And then finally, with the feedback loops. And this is something that's kind of obvious to say, but a good example of this is we have a client, it's a manufacturing facility. We're doing some robotic fabrication for them. And they have this fellow there, his name is Phil. And so Phil has been there for 30 years. You just talk to Phil, show him some drawings. He says, yeah, we're gonna build it this way, not this way. It's gonna cost this much, take about this time. He's got 30 years of knowledge in his head that he just automatically can analyze something. Phil's gonna retire. He's probably gonna retire in the next few years. So how do we take that knowledge in Phil's head and create a feedback loop to feed through our technology? It's a big issue because, as you recall, I said, for every person entering the construction industry, 3 are retiring. So how do we download that knowledge? So if we can do this successfully, it allows us, and it's allowing us right now, to really communicate with the construction industry. How do we overlap with all those things that the construction industry finds important? But more importantly, from an AI perspective, which AI technologies are we going to use? This just allows us to categorize the different types of technologies where we actually want to experiment into different areas. And then, I said this before, are we going to buy this off the shelf? Are we going to partner with someone to do that? People are approaching us all the time. Or if it's really important to us, do we actually develop it internally, and do we own the IP? And with limited resources, this is a very important conversation. So just to end off on just a couple examples of how we're doing it, I'm generalizing things, but I talked about the data that we need to capture. You know, if the industry problem that we're dealing with, it's all unstructured, how do we import this into our models? How do we make it queryable? And so if we can really identify that problem, all of a sudden we can have much better conversations with the technology world about how we can use machine vision, machine learning, or whatever the technology might be. Intelligent robots, I mean, one of the really powerful things that we're looking at is how do robots make decision in real time? So how does a robot decide if it wants to, pick up this, but this moves? How does it decide to move around everywhere? We can add some computer or some vision and some compute on the robot arm. We can help the robot make those decisions. And if we can do that, we can just reduce the need for human labor. We can lower setup costs, makes it easier to use robotics. And of course, there's a number of associated AI technologies related to that. Human-robotic collaboration is something I've referred to a few times. This is a really, really interesting area. A lot is going on at U of A and some fellows there about how robots and humans will work together. If we can do that, we can solve a lot of problems and reduce a lot of costs in the construction industry. And of course, there's a bunch of different technologies. You may have seen this image before. This is from last fall. It's just a frame grab from a video. And Google DeepMind released a paper, I think in October of last year, about their advances in robotics. And the video they showed was these two robots tying shoelaces, like in real time with no interaction from a human. It's really, really remarkable. So if we can get robots to do those fine precision things on site, it's going to, again, lower the labor requirements. We'll be able to design for robotic fabrication and, of course, very, very complex AI technologies, but it is, in fact, coming. So my point here for this framework, doesn't matter what industry you're in, if you're construction, like if you're a direct competitor to us, this probably makes sense to you. If not, the concept is very, very important if you want to commercialize new technologies. How does this framework work for you? What does your framework look like? How are you going to communicate these AI technologies into your business? Another really interesting thing to consider, especially today, is we're all going to use AI technologies in our companies. It's inevitable. We're using ChatGPT today. But do you actually need to build an AI-first strategy where AI is the actual platform? Harder to do, much more expensive and disruptive to your current business, but it's probably the right answer. But are you willing to take that risk and that bet into that space? Really interesting conversation. And then finally, are you going to buy, partner, or build? And I just wanted to say this because there's a lot of people in this room. If you have a problem you need to solve with AI, there's a good chance that someone in this room might actually be able to help you with that. I'm just going to end off by talking about what's going on here in Edmonton, Alberta in this space. And one of the things I really liked about Amii and this conference, it's all about community, right? So how do we actually benefit AI, to benefit society, but also how do we use AI to benefit our economy? So how can we actually I'm from Edmonton, I grew up here. How do we create new companies here? How do we create jobs, and how do we create wealth? And when you kind of look at how to create a successful technology company, and there's a lot of aspiring entrepreneurs here, I spent a number of years as an angel investor, investing in different companies. And what I found is, not only for me, but talking to VCs, if you want to create a successful technology company, there's a few different components you need to put in place. So first one is you need a big market with a big problem to solve in that market. You need some sort of disruptive technology or proprietary technology that can solve those problems in that marketplace. But you also need domain expertise. You need that subject matter expertise to apply that technology to the problem that's being solved. Someone has to know the industry inside and out. And if you can put those three characteristics together, you're going to attract capital. You're going to attract money, research money, venture capital. These are the key critical components for creating a successful technology company. So if you kind of look at this, and so this is kind of a key reason why I'm doing this with Robim, how does this apply to Edmonton? So if we kind of break these things down in the context of Edmonton and Alberta, already talked about repeatedly, construction's a multi-trillion-dollar industry. There's lots of problems to be solved, particularly labor shortages. We have a shortage of 3 million houses in Canada. The recent Liberal election, they're going to pump a bunch of money into this space. Big problems, big market. That's pretty obvious. But when we look at disruptive technology, why are we here at Upper Bound? AI is at a point where it's going to disrupt every industry in the world, and it's also at an inflection point, we believe, to really have an impact on the construction industries, particularly in robotics and automation. So as we know, or many of you know, Edmonton is a world leader in this space. We, of course, got Amii, the Computing Science Department at the U of A, number 3 institution in the world in terms of research output the last 20, 25 years. We have the talent that we can hire. We have to compete against a lot of people, but we can bring them into our company here. We don't need to move them from Edmonton. It gives us a tremendous advantage. And then finally, the domain expertise and subject matter expertise. I found out quite recently that my partners came from the U of A in the construction engineering program, in the engineering faculty of engineering at the U of A. Top school in Canada for construction engineering, one of the top schools in the world. People from all around the world are come to Edmonton to study at the U of A in their construction engineering program. That's how I met my partners, and then why we started the company. NAIT is the largest polytechnic in Canada. It trains all the people that are actually doing the building, all done here in Edmonton. And then, of course, Edmonton, if you're from here, you'll know that we're actually a world leader in terms of construction domain expertise. PCL, which I mentioned a couple times, they're largest general contractor in Canada, headquartered here. Stantec is a top 10 engineering firm in the world, headquartered here. A bunch of other companies, even if they're not headquartered here. I saw Luis from Ellis Don in the crowd. He's their AI lead. You know, Ellis Don's based in Toronto, but Luis is based here at Edmonton. They're getting this critical mass of expertise related to the construction industry. And I think just the companies that are headquartered in Edmonton, they probably generate $20 billion in revenue. So we have literally thousands of people that we can draw upon that can give us the domain expertise, subject matter expertise for this space. And if we can use those components to attract capital, the really interesting thing is construction tech, AEC, which is architecture, engineering, and construction, is having a bit of a moment in the industry. We're seeing a lot of growth in this field, interest from venture capitalists, specialized funds, larger rounds. We're really excited by this because we're getting a lot of inbound people interested in what we're doing. So we kind of put this all together. We've got a big market. We've got this really disruptive technology in AI. And as I pointed out, all of these companies here, I just gave you an example, there's one thing they have in common. Does anyone know what that is? Well, they're all Edmonton headquartered companies. They're all companies that are headquartered here in Edmonton. So we've got this really significant base that's already happening here in town. So I wanted to highlight this because I really feel now, in 2025, this is really a unique opportunity to be in this space. If you're a business person or a technologist or someone in between, you really want to focus on an area that's got growth and opportunity, this is it. And actually Edmonton and Alberta is a place to do it. We have the opportunity here to be global leaders in construction, AI, and robotics. So overall, just to sum up, the opportunity is really huge in this marketplace. I hope I've been able to communicate that. The timing's perfect to get involved, and I want to leave you with a challenge is, how are you going to get involved? What are you going to do in this space overall? So with that, I'll end. I want to say thank you very much, and I think we have a few minutes for questions if there are any. Thank you. I think there's a microphone up here if anyone wants to.
Hey, thank you for your presentation. I have one question about your robotics. So it's just like one robot doing stuff. Like, how about the handing of the material or something to the other robots?
Yeah.
Have you considered that one kind of the multi-agent robotic that can do like the whole thing as a factory or manufacturing stuff?
Absolutely. So we're developing as a module, but the next robot, imagine a robot on a rail that's doing processing on one side. It actually feeds material on the material rack. And then also another application is 2 robots working in the same cell. So this is the starting point, but absolutely for certain applications, we'll need multiple robots, and we'll also have to deal with the volume issue by scaling up the modules.
And also I have another question. So like you show like the kind of AI usage in the like construction, but I didn't see any example for the scheduling model, which is kind of huge part of the construction. Do you see any potential to use AI? I know there are some company like Alice Technology or Enplan out there that kind of in the state and the Brit like UK, but do you think like there is any opportunity to use AI in the scheduling because it's a huge part of decision making?
100%. I focus just on examples that are based here in Edmonton, but there are many examples, and some of the larger players that are, Procore and others that are already in the space, they're of course implementing AI things as well. So you have to look at the incumbents and what they're doing, but that is a huge area of opportunity for AI as well.
Thank you.
Hi, Bruce.
Hi.
Quick question. In terms of next steps, if you want to create a construction innovation hub here in Edmonton, what would those be? Who are the organizations that would be involved to actually catalyze and make something happen from this?
Yeah, great question. And actually, I think if I just found out today, in the next week or so, you might actually hear about this in a bit more detail, but we really need 3 areas. So one is we need the academic community. I'll just loosely call it the U of A and NATE. The University of Alberta, Ali Gobachi is somewhere in the audience. He runs the Construction Innovation Center at the U of A. So they play a role of integrating with industry and academia and part of that construction engineering program. So that's one area. The second area is really industry. So, the PCLs, the Clarks of the world, but all those other trades and subcontractors have to be involved. Companies like ours are developing new technologies. And then third area is really government. We have to instill some standards in this space. The government, they're responsible for regulations and building codes, that sort of thing. So there's certain changes we can make. And also, the largest developer or constructor in Alberta is the government, Alberta Infrastructure. So they have an opportunity to be an enlightened owner, to actually play a role in this space. And I think that's the opportunity where industry has to explain the problems to academia. Academia say, hey, here's what's possible. And then the government can play a role to kind of accelerate the process. But ultimately, it's going to be driven by industry.
And given that it does need to, I agree with you, I think it needs to be driven by industry, but you've already been kind of coalescing. What are some low-hanging fruit that could be either removed or some ramps put in to kind of accelerate this process?
Yeah, it's a great question. I think there's a number of things, of course, we can do. I think the easy ones are just double down on what we have already. Construction engineering program, U of A, Amii and on the AI side of things, can we actually get some, a research focus for that? I know Edmonton Unlimited is really trying to play a role of getting technologists together, help them advance their technology. And then the Edmonton Chamber of Commerce, they're starting to take a really lead role to convene, to say, what problems are we going to solve? So they can bring construction in, bring the technology in, bring them together. And that's probably been the biggest problem with my experience is you've got these silos. You've got these researchers aren't talking to the industry and the industry's not talking to the researchers. We need to break those silos. That's probably the first thing.
Thank you.
Thank you.
Hi, Bruce. I have a question. In robotics, synthetic data is commonly used due to the scarcity of real data, but its complexity increased the difficulty of AI models tuning. And I'm wondering how can we effectively use the synthetic data or any common data augmentation strategy as we continue gathering and collecting more and more data and avoid the tedious process of testing each probabilities one by one.
You and I need to talk afterwards. I will introduce you to my 2 co-founders who have their PhDs in this area. They will be able to answer your question much more effectively. But I think the key thing, the foundation is that we have to collect past data, current data, and real-time data. Everything's driven by the data.
Yep.
But it's an interesting notion. We are really running out of data. So this whole notion, Rich Sutton's recent paper about experiential data that he published a few weeks ago or a few months ago, how do we have synthetic data or how do we use our experiences on the construction site to feed that? Is a really interesting area. But find me afterwards and I'll introduce you to my partners.
Okay, thank you.
Hi, Bruce. Thank you for your talk. It's been really interesting. So I have 2 questions. One, I would really like to know what would you advise for people who are trying to make a career out of this field, because remote sensing and construction kind of go hand in hand. So I have a bit of experience in the field and I want to understand, so I want your advice. The second thing is that I want to understand how you're managing customer and client expectations, because from my experience, that's one of the hardest things when you go into these fields, because I think customers and clients are kind of new. Just AI in itself is new, but in this field
100%.
it's very new. And sometimes their expectation is like you're gonna have like 99% amazing results and everything is gonna make sense. But sometimes it doesn't. So as somebody who comes from a sales team, how do you meet with those kind of challenges, and how you make sure your technical team is aligned with those goals?
Yeah, so that goes to that platform, and so you need that framework. I would suggest that's helpful, so you can really show you understand the client's problems and the technology. So to answer your second question first, it's all about managing expectations. It's very easy for a salesperson to over-promise, under-deliver, so you got to do the opposite. What we're doing specifically is we're doing paid pilot projects. So we're curating a couple key companies that we know if we're successful with them, we're going to be successful in the marketplace. So they are wonderful clients. We're working with them hand in hand, and we're not developing the technologies together, but they're very patient with us so we can prove out the points, identify the new areas where we're going to have issues. And so we have developed this really close relationship with some pilot customers here in town. And if we can do that, can we translate that to a much wider audience? So that's about managing expectations. Your first question was really about remote sensing in construction?
Yeah, so I want to know what your advice is for people who are trying to make specifically their career, because there's a lot of boom of LLMs and other things that going on, but just specifically focusing on remote sensing, construction, and computer vision. What do you think? What would be your advice for those people?
It's not going to be exhaustive, but two thoughts come to head. So computer vision, what I'm really interested in is when we add computer vision to the robot arm and add some compute, we can add intelligence to the robot to do different things, to make decisions in real time, but also they can work more safely with humans. So just from integrated with the robots is the other thing. For remote sensing and computer vision more generally, we need to understand the physical environment. So if we can use vision and sensing, if it's drones or whatever it is, to really understand the physical environment in order to develop the digital model for that. Those are kind of two big areas that at least we're seeing. I'm sure there's dozens of other areas as well.
Thank you so much.
You're welcome.
Hi, Bruce. Thank you so much for your talk. My question is a bit out of scope on what you talked about today, but I wanted to just get your opinion, kind of related to construction engineering. So the area I'm interested in is on the customer experience. So how do you think human AI agents could be utilized in the construction domain? Let's say trying to get like the quotations from customers, what do you want to build, like being able to integrate that into your system. Is that something you'd like to explore?
That is a huge area, and just a couple things come to mind. We have a company we're working with, and we're going to manufacture some products for them, but they have to get a customer's design. They have to get all the drawings together and get it into their model, and we have to import it into our model. It takes them 8 weeks to do that. And it's just chasing information, dealing with different people, and this has got to be automated. It's just ridiculous. It should take 8 minutes, not 8 weeks for the whole process. So there's that whole area of kind of getting rid of using agents to get rid of these mundane sort of tasks. And then beyond that, the other thing that comes to mind is I mentioned Phil, the guy who has all this knowledge and information that when he retires, it's lost. Or when someone designs a new project, they go through it, they learn from that, but they don't actually feed that back into the next project. So I think there's a lot of opportunities there. How do we download the human experiential data in my head down into a model somehow, or some sort of AI to take advantage of that? So I think if you can solve problems in those couple areas, there's a lot of value can be created.
I'll probably want to chat with you more about it.
Sure. Yeah, thanks.
Hi, that was an excellent presentation.
Thanks.
Thank you. You spoke about how the intersection of AI and construction is prioritizing making up for our housing deficit. And I'm just wondering if you can expand that more to making housing accessible for those with disabilities.
That's an interesting question. I think that really comes in on the design side of things. And this may not be 100% related the answer you're looking for, but one of the things that the design world today, they'll take the needs of a client, but what they're doing is actually design it based on humans' fabricating it, like human construction. So I think it's a really interesting area. How do you actually instill all these needs into a model that we can design for robotic fabrication? So humans are really good at putting things together in 90-degree angles. We're working on a project that is actually has 250 different pieces where every single one is unique, that's creating kind of this gazebo pavilion thing. Impossible, well, not impossible, but very, very difficult for a human to do that. So I think by the promise of construction, robotics, and AI, is we can open up a whole new design field and opportunities to address people with very specialized, issues in that space. But I think mostly it goes back to the designer, how to give them the tools to design with the needs of someone with disabilities in mind or some other special need.
Very cool. Thank you.
Thanks. All right. Unless there's no more, thank you very much, everyone.
All right, hi everyone. So I did complain that this talk is probably mistracked in the business of AI. While we are venture funded, we're very much a research effort, so it will be a little more technical than maybe some of the other talks here. And now, I know there's a little bit of an impression that Keen Technologies has been a little bit secretive since it's been announced a couple years ago. And it's not really because we're intentionally being secretive, it's just we're not raising money, we're not selling a product, so we've just been kind of heads down working. But I am happy to finally start talking about a little bit about some of our directions here. So, and also I have managed to go 35 years in my career without making a slide deck. This is my very first one, so apologies if it looks like a middle school project. So background-wise, I started out in the early 90s founding id Software, where we made a lot of foundational video games, kind of defined the first-person shooter genre. But relevant here, the original Quake, or its GL Quake variant, was kind of the prime driver for the early adoption of GPUs. And a couple books on NVIDIA recently have kind of called that point out pretty specifically. And I feel quite good about that. It's kind of led to the AI world that we're in now. And then a little bit later on, some of the games like Quake 3 Arena was used for the DeepMind lab, although sanitized of all the kind of action and violence for generic task work there, but another little AI tie-in there. The latter half of that, I also spent some of my time doing Armadillo Aerospace, building vertical takeoff and landing rocket ships. Interestingly, it was founded basically the same year that SpaceX was, to substantially less general success. But there's some lessons in there that I enjoy talking about. You can grab me sometime after the talk if you want to hear more. But then after that, I laid down most of the current foundational technologies for the modern era of virtual reality for Oculus. And this was a big systems engineering task around kind of minimizing latencies through everything and figuring out how to make things cost-effective enough to work on mobile systems. And the current Oculus Quest, I'm very proud of. I'm proud of what we accomplished there. But I did wind up parting ways with Meta eventually, largely because while I was there, the OpenAI founders, Sam, Greg, and Ilya, tried to recruit me. And I was pretty flattered by that because I'm not an AI guy. At the time, I was a video games, maybe a perception, and I'm kind of analysis sort of person, but I had largely not paid that much attention to all the exciting things that had been happening in AI. But once they kind of prodded me about that, I sat down and I started doing the reading, seeing what the state of things were, where I could possibly fit into it, and it was really exciting. It was to the point where I looked at this and thought, this is actually the most exciting thing anybody could be working on right now. And someone in my position, deep technical background, the freedom to do whatever I want, it was clear to me that this is actually what I wanted to work on. Now, I had started off in sort of what I called it Victorian gentleman scientist mode. You know, the idea that I'm a wealthy enough person, I can go do science by myself and research the different things. But I had a number of people that kept pushing me. It's like, no, you should spin up a company, we should get some resources to you, you should hire more people. And eventually I gave in on that. And we did take some venture money, and we now have 6 researchers working at the company. And it's been, it's been a great journey for me. One of the real kind of surprises was joining up with Richard Sutton, where part of my doing the reading and the research phase of, I call the larval phase of getting into any new technology, was reading his textbook, twice, and going through that, and then finding out a year or two later that he actually wants to work with me on this project. And there's a lot of strong alignment between the Alberta plan and the way I think about things. The general hotness, where we had LLMs being everything. Everybody, like all the cool kids, are doing an LLM startup and raising huge amounts of money to do things. And I am amazed and excited about all the things that are happening there. I'm a daily user of many of these technologies, but I do still look at this fundamentally as that LLMs can't be the whole answer. These transformer-based models, it's not the way a human brain works. And what they do, as magical as it is not handling so many of the fundamental things that cats and dogs do, let alone small children, where a lot of people don't, they imagine that these LLMs are reading all of these books, reading the whole internet, and they don't understand that, no, it's taking all of human knowledge, putting it in a giant blender, and then training from there. And it's magical, it works really well, but when you're put into a situation where you have to learn something new, there are fundamental things that so many of the researchers here are working on that are just not understood yet. We do not have even a line of sight to an answer for these things. And this was the change for me, where everything that I've done before has been some kind of engineering where even if I'm doing something newer or better than had been done before, I had the line of sight. I knew what the endpoint was, and I had a pretty clear idea of what I had to do. Where this is doing science, and this is trying to find knowledge that nobody has right now. But it does feel like it's the time of all the happenings, where the next few years is where things are really going to happen. And so I had an obvious background in virtual environments and games. So this idea of simulation and working with games just kind of naturally flowed from what I was doing. And I think that that's still a very valid direction. There is this other side of touching reality and finding the things that are the limits of simulation that that we'll get back to. But at the time, I thought that video understanding was going to be one of the necessary steps to tie with all of these problems with game playing and reinforcement learning. So I kind of imagined this infinite video wall that was interspersed with regular TV content and interactive games. And I was going to set out to have my agent learn how to play multiple games in a continuous environment with intrinsic rewards and all of these standard goals, but interspersed so that it also had the ability to learn from static video feeds, like human beings do as infants. As it turns out, I kind of think I made a few missteps that were somewhat predictable in some ways here, where I started out as Mr. Low Level. I'm the guy that writes assembly code or CUDA kernels and does all of this, and that was kind of looked at as one of my core strengths. When I started doing AI research, my first several sets of programs were built from that standpoint. And there is great value in kind of learning the very nuts and bolts and knowing exactly how something is implemented and how something might be done differently. But in hindsight, I look back at it as a mistake. I can look at how I migrated up from custom CUDA kernels to using cuBLAST, to using cuDNN, to using libtorch, to eventually I'm in PyTorch like everybody else. And it's a good thing. I also probably avoided some large-scale cloud utilization longer than I should, where I again had a little bit of a bias towards physical hardware. I like the idea of running something on a GPU that I could put my hand on and hear the fan whirring on. I spent too much time kind of like working in notebooks before eventually migrating towards spinning up cloud instances, using Visual Studio Code on remote systems, and kind of working there. Another thing was, just to sort of be contrarian, I had started off working with Sega Master System as my kind of gaming of choice, which nobody had worked with. And I thought, well, this will be interesting, sort of untrod territory. It's a little bit of a step up from Atari in terms of complexity, but not having any baselines of anything else to compare against was a mistake. And then I also decided that the video understanding really can wait, that so many of these core problems that I look at as the unsolved science right now can be handled with just sets of games. Not necessarily single game learning, but we can build a rich environment out of sets of different games and address these kind of challenging science problems. So we did, perhaps boringly, decide to settle in with Atari. And the Atari learning environment is, it's born in Alberta, and it underpins so much of what happened in dynamic reinforcement learning. And there is a little bit of this sense that maybe it's played out now. Is this not where the hot research should be going on, that there are other things that might be better? But I do really think that it's got all the necessary things. And some of the critical aspects are, the diversity of having 100+ different options there is valuable. Being unbiased by researchers is, I think, undervalued, where anytime a researcher builds their own benchmark, builds their own kind of environment to play in, it is unavoidable to have a bias to not do the things that you think are going to be hard for your algorithm. You've got your problem you're trying to solve, but there's always a whole host of other side effects for things. And if you build it yourself, you're going to build something that's not going to do horrible things to your algorithm. That's just the nature of humanity. While the Atari games were built for humans to play, they were built before any of this research even existed. So they exist there as an unbiased sample of challenges for us to undertake. And there are huge challenges where you might get spectacular performance playing one game, make a change, and it's better there, but then it's worse in another one. And this richness, I think, is sufficient for a lot of these things that we want to do. Now, the standard Atari games, the way since DQN 12 years ago or whatever, have been tested in this regime where you take one agent, you train it for 200 million frames. And that's a lot of playtime. It's like a solid month of playtime, just 24/7 running a game like that. And as far as scores go, the very latest agents, things like Muesli and Meme, they are generating highly superhuman scores on almost all of the games. So it can look like it's solved, like, okay, we can destroy these games better than any human can. But there's a lot of other aspects to it where learning quickly is a good thing. And I understand it's not a well-loved benchmark, but the Atari 100K benchmark that people have been doing for the last few years, I think is a really good way of addressing that, where saying you've only got essentially 2 hours of gameplay to learn how to play a game. That makes it much more challenging. And you could take these very great world-beating agents and say, you've got 2 hours, and they don't look nearly as impressive. All of these games start off looking terrible, and it takes a while for them to get up to the point where they're doing something interesting, let alone something superhuman. So I think there's still a lot of good value here. Now, the spectrum of choices for environments, on the one hand, you can start with something like grid worlds, where you've got these synthetic academic environments where you test a very focused and specific thing. But obviously, that's really limited. And on the other end, you can have sophisticated real-world interactions like, self-driving cars is a crucible of all the problems of real world tied to reinforcement learning, or not reinforcement learning exactly, but machine learning in general. But in between, there's a spectrum of games where Atari was sort of the grandfather of all these games, and they're simple, generally scene-based games. Common question is, well, why not something modern, something that people play today like Pokemon or Minecraft? And I know it's the same argument that pushes people towards grid worlds, but if you can solve a problem or if you can grapple with a problem in a simpler environment, you probably should, rather than having unnecessary complexity on top of it. So it's still kind of a judgment call there. But also, when people undertake working in these modern games, the temptation is so great to look beyond the pixels and look at internal data structures. And honestly, I still just look at that as cheating. It's a way to get your agent to do something that looks interesting in a relatively reasonable amount of time, but you're bypassing most of the hard problems. If you're checking on inventories or positions or something, you're not worrying about maintaining your track through a history of experience. So Atari's a long ways from being solved for all of these hard problems. One of the big points I want to push on the broader community of people that are playing a bit with Atari in the research community is this, that reality is not a turn-based game, where the classic RL system right now is a simulation environment where you've got your agent, you call off to the environment and say, here's what I did, tell me what happened as a result of my action, and it pushes back a new observation and a reward to you. And that is very much like what a board game is, like chess or Go, and RL has done really spectacularly there. It's not like most real-world interactions. And now it's true that things like the cheetah and hopper and those kind of continuous RL tasks do have many more of those kind of complications, but they're also then tuned towards these are research toy problems and don't have some of the other richness there. So I do push for this, for the Atari work, anybody that's working on that, to sort of invert the RL environment, where think about the environment calls the agent. You know, the agent just gets called, the environment probably keeps going, keeps on doing its business. If you take a really long time to come up with the next action, it will have gone and done many things after that. And then if you're actually working in real time, you have the issues of you just can't spend all of this time. Like some of the really spectacular results that have happened in the last few years come from like replay ratios of 8, you know, training 8 times as many times as you're actually making an action. And these take much longer times, or building diffusion models or other things that take days to run to generate hours of gameplay. These are interesting from a technical level, but they're quite far from this solve a problem of acting in the real world. And the latency in particular is a killer for many of these algorithms, because many of these algorithms condition on the action that's taken. They say, I'm building a world model, or I'm building a self-predictive representation, and it's conditioned on this action that I'm telling the environment. And that works great. It delivers these fantastic abilities on a simulator where it's waiting for you. You get your observation, you make your action, it processes it, gives you your reward and next observation. But if that action is going to take a dozen frames or more to actually have an effect, this simple conditioning on next reward doesn't work at all. It's just going to be random noise. And these spectacular algorithms then pretty much fall apart. But then there's the other questions of like, how else might sensing from reality differ? And we did this kind of as a stunt, but it's been a pretty valuable learning experience for us in a few different ways. But this idea of like, what would it take to actually play a game like a human plays a game, not in simulation? And one of the things that I've been telling people that are kind of like, oh, the singularity is near, in a couple years robots are going to be doing everything. It's like, take your next dancing robot demonstration and ask it to pick up a joystick and learn how to play a video game that it's never seen before. These are capabilities that are nowhere close to happening in these types of systems. You know, not only does it not have necessarily the dexterity and latency on the loop to kind of do that effectively, but the fundamental problem of learning some of these things is still hard. And then learning it in an environment with all of the other things going on around it instead of just being fed exactly what you need for this. These are challenges. So this pitch, and we've got it in the demo like over there by the curtains, and everyone should go look at it. This is a setup where we have a camera, a little robotic servo, joystick stuffed in there, and it's running, not particularly exciting RL agent, but it started learning this morning, and it's up to kind of mediocre-ish performance now. If we let it run for a couple days, it'll get to better and better performance. But this was just a test of what do you need to do to make RL agents that work fine in simulation behave okay in the real world. And we will be open sourcing this work, both the physical aspects of it, the 3D printer files for the joystick controllers and our frameworks and the RL agent and all that stuff in there. We learned enough just from setting this up in public here yesterday that we're going to do a couple more iterations before we wind up making it public, but it'll all get out there eventually. So some interesting system design choices on this. Most Atari games are set up so that you have to reach up to the console and pull a little reset lever to restart it. But there's at least a number of them that you can restart just by pressing fire on the joystick after you've died. So we picked, there was a dozen or so games that we found that could work like that, where you could play it just with the joystick and restarting there. So we didn't have to add another servo up on the console itself. So we've got Centipede, Up and Down, Q*bert, Defender, Miss Pac-Man, Krull, Atlantis, and Battlezone. Now, we had a couple other ones that also worked here that we had to disqualify for some other interesting reasons related to the score availability. The compute we're running on right now is just a gamer laptop. Laptops are a little bit frustrating. We were pulling our hair out a little bit last night why performance was down because it wasn't fully charged and it was in a power saving mode, throttling the GPU, all the miserable things dealing with that type of stuff. But you can get a 16 gigabyte 4090 equivalent GPU in a laptop, and that is enough to run sort of most classic deep RL algorithms at a frame skip 4 level. The compute is, there's lots of fun optimization stuff to do, and I always I feel the draw of rabbit holing down in optimization, both in compute and latency end to end. But just a couple quick things. It's like I am a big fan of CUDA graphs, where the entire thing that's running there is one CUDA call to the graph, and it does everything. It does the policy evaluation, it early outs to let the rest of the real world go on while it's doing training for the next set of things, and that's been a pretty efficient way to do things. We've got fairly standard kind of live streaming camera setup, but there are some things to watch out for in cameras where some of them don't have full 60 frames per second, or they do JPEG compression where you really want a low latency, uncompressed stream. It does 1080 natively, but you don't need that for Atari. Atari screens are only 160 by 210. They're very low resolution. But there may be some reasons that you want to run higher resolutions for things like identifying tags around the screen, score box, and various things like that. 60 frames per second was fairly important. I had hoped initially that we could just use the laptop webcam, just open up the laptop, point it at the screen, and have it work there, but that was only 30 frames per second, not acceptable there. Now, we expected some set of problems with scan out. Anybody that works with cameras and displays knows you've always got the Genlock problem about your screen is refreshing, maybe theoretically at 60 while your camera's at 60, but they're not in phase and they're always slightly drifting. So it's probably more of a problem for kind of scrolling games that have full field motion, but the only thing that it caused us trouble for in Atari was the big thing that I'll get to again, which is this score box identification. Sometimes we're looking at a score to tell what the reward's going to be, and it'll be split in half, and it'll mess up the digit kind of recognizer for it. So the rectification of looking at the screen. This was an interesting thing. We started off not doing anything. You just stick a webcam down, look at a screen. It's got all sorts of other stuff in the background, nothing kind of routed out, and it still learns fine. Basic convnets are really surprisingly resilient to learning whatever random distortions you might have there. But if you hope to be able to take this and then reuse it in a different place, you need to be able to just pull out exactly what you want from the screen. So we went through a number of different experiments. We put in, they're called April tags, these little fiducials that robotics people use a lot to identify things, and we just kind of stickered those onto a screen around the game field that we cared about. We could identify those, and then we could pull out a nice rectified image of the screen, and that worked really nicely. You could move the camera around, it kept track of the screen everywhere, and that's sort of what you would imagine your humanoid robot leaning around playing a game would wind up using. But we had miserable problems with a sticker is a reflective thing, the screen is an emissive thing, and lighting conditions changed, made that fairly unstable and kind of difficult to use. It also kind of wanted higher resolution for that, but at 1080 it worked okay. What we want to do, and what we're probably going to go back and do after we get back from the conference here, is do some more generalized screen detection where it knows what the background field of this game looks like. It should be able to just identify that, rectify everything from that, just point it at a screen, it figures everything out. But that's going to be a little bit more work. On the output side, the first thing to try is just wiring up a little digital I/O. All of these RL agents, they just spit out, here's your action from 18 different possibilities, 9 different joysticks, button up or down. And the Atari joystick is a nice simple thing. It's not like a modern controller that's sort of a USB spec. It's just pull these lines down to ground, and that's what your joystick does. So that was pretty straightforward, but again, it's not really real. It's kind of talking to the computer on a computer level rather than a physical level. So what we've got now is what we call the Robotroller, which is a little robotic thing that you literally stick an Atari joystick in, and it's got 3 servos for 2 axes and a fire button. And this does add some additional latency, which is expected, but the somewhat surprising thing that we didn't think about is there is a problem with physical things when you move from, say, like one diagonal axis to another diagonal. There will be intermediate steps along it there will be phantom actions. And then the fire button is independent of the other 2 axes. So we've got problems where a game like Atlantis, where you're kind of shooting from these turrets on the side of the screen, you push the joystick over and press the fire button. The agents just say, I want to be firing from this side, and they kind of shoot the shot up that way, but then you run it on the physical system, and the joystick's trying to go over, but it hit fire before the joystick got all the way over, and it just does terrible. Now, this is one of those cases where the way people do Atari is you just feed in an observation, but this is an example of where you need to be feeding in the reward as well. I mean, not the reward, but the action. It needs to know what you tried to do in the past. So here it needs to learn, don't press fire until a couple frames have gone by after you asked it to go ahead and push over to the right side. And another example I mention a lot on that is like the old Konami code for old timers when you remember you're going up, up, down, down, left, right buttons to get cheat code access to some old Nintendo games. That's the type of thing that the standard Atari interface that people use is never going to be able to actually issue because it doesn't know exactly which buttons it's pressed. It's part of the unobservable state because it makes no impact on the observations. So robustness issues. We have worn out servos and a joystick so far with this when you just let these things sit and churn overnight, pushing the joystick all over, especially in the kind of spastic way that RL agents early in training tend to play, lots of kind of vibrating back and forth. So figuring out did your RL algorithm just fail because the score is terrible, or did you actually wear out one of the buttons on your joystick was another point. So Khurram did some really nice timings here looking at the actual latencies. And these seem shockingly high for people that, that are used to thinking in smaller numbers. But with the robot controller, we're looking at 180-ish milliseconds end-to-end latency of having it move from one side to the other. And there can be even more latency in the systems with the camera and the actual processing. We know that the processing is going on at this 15 hertz rate, where it's definitely not taking more than 60 milliseconds to process, but this whole chain of things that go on after that and before that add up, and it looks like quite a lot. Now, of course, this is what I did in virtual reality, was fighting the good fight and bringing all that down so that the motion to photons latency was only 20 milliseconds, which was kind of the limit for not causing people to be sick moving their head around and things. And we could have fought that here and tried to get really far down. Like, an interesting thing is we're using this modern system called an Atari 2600 Plus. And inside, it's just got like a little Raspberry Pi running Stella. It is not like a rebuilding of the original Atari system. So just that system adds 50 milliseconds over, versus if I dusted off my actual Atari 2600 and we plugged it into a CRT monitor on channel 3. But the point is, these are numbers that are roughly human-like. If you've never done this, you should do search on like human latency testing or click latency testing. You go to a little website and they'll just like flash a color and click as fast as you can. And while there actually are latencies in their test bed that are worth noting, you get numbers like 150 to 200 milliseconds. So these are not crazy numbers to be learning with. Now, surprisingly, the thing that turned out to be by far the most problematic aspect of this project was reinforcement learning algorithms need a reward. They need a reward to chase. So normally these come from like the ALE looking at internal memory locations and saying your score went up, I'm going to give you a reward here. But in our situation, we had to look at the screen and figure out what the score was to give a reward for that. And that seems simple, like MNIST, haven't we been doing this forever? Isn't this what AI just does? And you can take a screenshot, you can ask ChatGPT, what's the score on this screen? And it'll just tell you. But it turns out doing this with relatively little data to sample from in terms of different locations and across different games is actually kind of tough. And while this isn't hardcore ML engineering, it's systems engineering that we really aren't quite through. We're still kind of messing around with issues here. We identify a little box of score and run models to find out the digits, but this morning we were finding that the tablecloth on the demo table over there was shifting slightly, and it was like moving right out of our little score box. Didn't affect the convolutional net running the model, but our score detector was having problems with this. So it's frustrating that that's still not super great. So one of the things that we've done that's a little bit halfway is made a custom little dev box. So it's not an actual Atari, but it's got an Atari joystick port, and it can go ahead and throw up these extra fiducials on the screen so that you can still have a camera, you still have all the challenges of dealing with real world lighting and everything, but it makes the score problem a little bit easier. So it's not as cool as actually running on real hardware, but it lets us kind of grapple with some of those issues. So what we've learned from this aspect, and this was never like a major goal. A few months ago, we just kind of decided it's like, oh, can we put something kind of fun together before Upper Bound? And it's been a worthwhile effort and bringing everybody together, feeling like a product push. But the ConvNets basically work fine for real world issues as far as looking at different amounts of glare, different screens. Learning in place works great. We have not necessarily demonstrated transferring to different locations, and I expect that there's still a set of interesting little challenges for us to do to say what is the invariant representation internally that's not going to care what your lighting conditions and what your monitor kind of curvature or anything like that is. The standard TD learning algorithms work fine with extra latency. It varies by game, where some games like Breakout with fastballs zipping down at you, they're very sensitive to it, and scores drop reasonably precipitously with adding stuff. But many other games, Miss Pac-Man's not very latency sensitive. The way a human plays, you push the joystick over well before you're making a decision. But when we've taken BBF, the bigger, better, faster Atari 100K kind of top dog, it generates really, really impressive learning scores in 100K frames. But if we just add a few frames of latency in there, it falls apart. So like our agent, which again is nothing particularly special here, it learns much faster than Rainbow, but not as fast as BBF. But add a few frames of latency to BBF, and then it's well below that. And I don't want I want every researcher to add a delay queue into your, right before your environment. Just put a little flexible delay queue where you can tune in up and down how many frames you delay. But please, nobody solve this by just adding a matching delay queue somewhere else before you get to your action conditioning. We want a better solution, like feeding all of your actions in as part of the observation and let it figure out as different things change. So the action path problem of like phantom actions in the middle or not having the different reward axes or the different action axes synchronized, that's a little bit interesting issue. And then it does decent learning. So the demo over there, one of them was restarted this morning. One of them was running overnight, but we had our little issue with the tablecloth moving the score there. But this is small integer number of hours, and it's playing reasonably well. It's not human level scores there, but if you let them play for days, then they do get up there. So the basic idea of the classic RL algorithms do work in a robotics environment for this stuff. And it does look like human level performance is probably feasible. But now, the real thing that we're working on are all of these major RL tasks, the things that several of these other talks have talked about, the same basic things, because these are fundamental problems that are unsolved. We're taking our good stab at it, and it's going to be in the context of suites of Atari games. So the sequential multitask learning, when people first heard about Atari games being played, you hear this model plays 57 Atari games and it plays them all well. Some people didn't initially realize that no, each one is trained. You can make a model that plays Breakout, you can make a model that plays Pong. Even though they're very similar games, they don't play the other games well at all. And interestingly, if you just try to learn in sequence, you learn Breakout for 5 hours, and then you learn Pong for 5 hours. You go back to Breakout, and it's largely destroyed. It picks back up a little faster. Not everything's gone, but it is very much not a human-like system. And people have solved this where if you train them all at the same time, all together, that works out okay. You can make that work as long as you normalize the scores in a certain way. But again, not how humans work. There's real problems that we have that we don't know how to solve. It's also, in my view, cheating to have a task ID passed in to let the model know it's like, hey, this is a new task. You should swap out weights, change out layers of your model or whatever. It needs to be a model that just takes what it's given, because there's no moral difference between going to a brand new level on a game and going to a brand new game. There's still challenges in the continuous learning that you need to work with. Because one of the things that I think even many researchers don't fully appreciate is the damage that happens in every update to a model that makes continuous learning like this so challenging, where the idea that you might train a game for hundreds of millions or billions of frames, but every optimizer step you do changes essentially every weight. If you've got a feed-forward ReLU network, 1/4 of the weights are changing, but with convolutions and batches, every weight is changing, which means every response to every observation is changing. And you hope that you've done something based on your little mini batch, you're improving performance there, but you're affecting everything else. Now, ideally, there would be some positive transfer learning where this is actually helping everything else, or maybe at worst, it's a random walk. But even a random walk takes you into meaninglessness after hundreds of millions of frames. And this is one of the, this is one of the points that I argue with Rich a little bit about the virtues of replay buffers. It's like, does a giant replay buffer solve it for us? Where we have tons of memory. We got 28 terabytes of NVMe data and storage that we could put things on. Does that just solve it? We're going to run that experiment here within the next few weeks. See if that works, but there are smarter things that we have to be doing about that. And another challenge of that is if you've got things that you learned a year ago in sort of subjective agent time, if you're still churning on that and you're learning from that, you're in sort of an offline RL problem. And offline RL is much harder because you're not testing what you're changing. And you can have this kind of coherent fantasy where, wow, I've bootstrapped this into a spectacular thing. Maybe next month when I actually come back and play this, it's going to be good. But more likely it's going to be terrible. So there's some other challenges with that. And then related to that is the transfer learning, where all of these RL agents, if you just start them up, they look like idiots. Like, what are you doing? You can walk over there and look at it playing Miss Pac-Man, and even after several hours of training, you're like, why did you just run into the ghost? Why did you just move back and forth there for no good reason? And the model is that these are like an infant opening its eyes for the first time. And that's actually then kind of impressive that in a small number of hours, it's like the fawn getting up and starting to run with no extra training behind it. But if you have played 10 games for a month each and you get to a new game, you should be able to play it decently. You should be able to understand how games work and what you need to do to make progress, not randomly bumble around with the joystick. But this has been almost completely failed for everything. Just as I was kind of starting with this, or I found OpenAI had done this challenge with Gotta Learn Fast, which was a challenge using Sonic the Hedgehog game, kind of a somewhat more modern game than Atari. And the idea was they let you train on all the existing games, and then they were going to test you on a brand new, never before seen map. It's like, great, this seems like a really excellent test. And nobody demonstrated any transfer learning. The winners just ran Rainbow and had reasonable tuning just to learn in those 1 million steps. And then it seemed exciting where the Gato agent, the transformer-based learn to play all the Atari games, first of all, it didn't actually learn to play them, but it learned to mimic pre-trained outputs of another agent. But they demonstrated negative transfer learning, where if you took a model trained on a dozen agents, and then you said, okay, I want to learn a new game through fine-tuning, it was harder to do that than to train completely from scratch. So clearly, we've got something that we just do not understand. This is a problem. And this is a little bit distinct from the continuous forgetting, because even if you were forgetting the old models that you learned, you should still learn the new ones faster. They're kind of tied together, but they're a little bit separate problems. So I'm hoping to get some traction behind getting the research community to agree on a new benchmark based on Atari games that sequences through them sequentially and then tests on like the last cycle of them. And a problem with a lot of benchmarking in ML, it's driven almost all of the advances really, chasing number go up. But in most cases, these have been kind of ad hoc specified benchmarks. Like all the reports for Atari numbers, it's like, well, somebody makes their own training framework and they work on Atari for a while and they post numbers. And there's all of these important little details that are often elided even from the research papers or are not reproducible. I think there's a value to making a harness that calls your agent through this extremely simple interface that is just like, okay, agent, you have been told, here's your observation, here's your reward, give me your action, and the environment goes on with no control that you've got over it. I think that is the right way to kind of address these problems going forward. And then all the details about it should have sticky actions, so it's not a deterministic thing. It should use the full action set so you can go between all the different possibilities. And we're going to do a bunch of these experiments kind of in the coming months, but I'm hoping that we can actually get some community buy-in and draft some more people to be kind of bench checking us against other things. Sparse rewards is one of the other major things where in real life, almost never do we have the density of rewards of a video game where it's saying score go up, sometimes multiple times a second. And classically, the Atari games that everybody had the most problems with, they called them the hard exploration games like Pitfall and Montezuma's Revenge. And those were games where you might play for minutes without getting any reward signal. And if all your agent's doing is bumbling around until it gets it, that's how you got some of those runs that required 20 billion frames to start delivering really good scores. So there's something important that needs to be done there. And it's noteworthy that even on a video game, humans usually aren't looking at the score nearly as much as an RL agent does. If you actually play games, when you die, you'll look at your score. When it's game over, you'll look at your score to see how you did. Maybe if something unusual happened, but usually you're concentrating on the action. The score is something that's going up there kind of off in the corner. And historically, it's interesting where my old video game Doom was the first major game that action game that didn't have a score. Up through there, all of our previous games, the Commander Keens and Wolfensteins, we were arcade people, so we had lives and scores. You ran out of lives, it's like you had to put another quarter in. And it was kind of funny that it took that long to realize that these games at home, you own the game, and maybe that's not the best way to direct play. But modern games generally don't have scores like that. So we need to get more towards these intrinsic rewards and curiosity and letting the agent figure out exactly what it's trying to pursue. So exploration is another one where the classic DQN approach is epsilon greedy, like every 100 actions pick a random action. This is clearly not the way any human works now. Policy-based models work a little bit better where you can avoid doing some of the tragic things like falling off the side on Qbert, where sometimes actions are super, super important. Every time you're sitting on the edge of a Qbert level, you hit the wrong action, you die, as opposed to Pong, where you're moving up and down in a kind of continuous way and it doesn't matter that much. But modern game controllers, like picture of an Xbox controller there, Atari gets by okay with a discrete action space of 18. It's got 9 directions for the joystick, 1 button. Every button you add doubles the number of actions there. Every new joystick you add multiplies it by 9. So even disregarding the fact that some of these are analog inputs, a modern Xbox controller has over 1 million actions possible. Clearly, that's not going to be a discrete action space, and you're not going to be modeling it that way. So we've done experiments with factorizing the actions into like each axis, which kind of addresses the issue with the RoboTroller of different latencies for that. But it's an interesting thing. But then timescales are another interesting thing where traditionally Atari games work in this frame skip 4 regime where you make one action, you repeat it 4 times. And this causes the characteristic buzzing of the reinforcement learning agents where they're just kind of moving back and forth. Humans obviously have more directed goals, like I want to get to that edge of the level, I want to go grab that item. And this seems to be where options in RL research apply, but I've yet to see a useful application of that to Atari games. You know, we're gonna try. One thing that Atari is unfortunately not good at is we need to have recurrence in our models. You know, the brain is a recurrent neural network. We digest prior information into a more limited state that we kind of maintain and do continual updates on. But for Atari, since they're mostly playfields, the standard practice of taking a handful of frames and just providing that history works well enough. We're still not seeing any real benefit from introducing recurrence. We're probably gonna have to find some different tasks for that. I'm pretty much out of time here. I've got all these things that are actually nitty-gritty technical details that I will probably wind up posting these and maybe talking over it sometime later. But we can actually go to questions and let that direct now as the timer ticks down to 0. So. So do we have a microphone out?
Hi, John. Thanks for the talk. I'm wondering about the benchmark that you proposed, because one thing that I have been very critic about the Atari 100K is the fact that people start to optimize for the length of the training process, right? Like, I can crank up my step size, and if I crank up the step size, I know that I will hit a good thing by 100K, but it doesn't mean that if I trained for 200K, this is going to work. And I really like the vision that you laid out here, but it seems that this benchmark, when you start thinking about doing the sweeps, and then you have this very short time period focusing on learning fast, aren't you opening up yourself to this type of over-optimization that you've been so careful to lay out the places where people would cheat? And this has been always my complaint about the Atari 100K. It feels that's a little bit too easy to cheat. And it also ties a little bit to exploration, right? Like, because then in the short time frame, it ends up being much more a matter of luck on whether you hit the bullseye within that time frame or not. So you're also opening up yourself to the variance of this performance.
Yeah.
So I would love to hear your thoughts about this type of stuff.
Yeah, so those are very real issues, and these are things that I want to have discussion with everybody about, because normally the variance is huge on there, and we would like to say like train for longer times, but it still needs to be something that the experiment velocity needs to be fast enough where you need to actually be able to do experiments. You can't have something where it takes a month to tell whether your idea is good. So this idea of maybe 8 games, 3 cycles, it's roughly the compute of running one Atari 100K. I'm open to people saying, no, we can handle more than that, but I suspect a bunch of people working on things are like, that's already a little bit of a stretch to tie up resources, because as you know, you need to do like 20 different seeds just to have some statistical certainty about it. Your single run can have wild variance in the different numbers. And as far as the actual things like, I don't love BBF's model resets every 20K because your performance plummets at that point there. One thing that I want to have is no explicit evaluation phase. I do think in the big benchmarking, I think Muesli did it right, where they were full action sets, sticky actions, and it was not a dedicated evaluation. It was like the last 200 episodes in the training. So thinking something like that where it's the last set of episodes, so if you're doing model resets, you're going to get some 0 scores kind of thrown into your average to at least partially penalize that. And as far as the exact switching, there's like a question of, do you switch exactly at episode boundaries or do you truncate? Because an interesting thing happens. If you just truncate randomly and you don't specifically handle that, it will seem to the agent like a bolt of thunder from the blue just destroyed them. And we saw some significant negative training when we were doing that, but you can pass in an explicit termination signal. So I don't know. The question of, I would think letting it train complete episodes so they're not aligned with, say, changing every 100K steps is probably better, but I am open to this. But I do think even a bad benchmark is better than no benchmark. You've got to measure something. If it's just random conclusions and abstracts on things, if it's not measured against something else, I think it's too easy to have mirages of value. So I'd rather have people gaming the benchmark than not running the benchmark at all. So buy-in is more important to me than making it sort of cheat-proof. And then you just use community approbation. It's like, well, that's totally a cheat. Nobody should pay attention to it.
Yeah, thank you for pulling the curtains back a little bit. You talked about the difference between like explicit scores versus intrinsic reward. You have a lot of experience building interactive systems that engage humans' intrinsic rewards, things that we would play without even looking at the score. I'm curious if you have thoughts on like differences between designing machine intrinsic rewards versus what engages humans. Are there things that we shouldn't transport from human curiosity?
So that's a very interesting question because, I mean, humanity is our existence proof of the intelligence that we're trying to mimic. So the question of how many of humanity's quirks do we emulate to try to show that? And I think there's some obvious ones that you do mimic, like this idea of you reward agency on some level. I mean, knowing that you're controlling something and you're making something happen, and there's something about visual field effects, like the more things that happen, the little pixel twiddling is less rewarding than the gigantic explosion over the whole screen. But when you get down to some of the specifics, it's less clear. Like there are sort of, people reward hack the human mind and things like online gambling and the different things where you can sort of work out your reinforcement schedules to maximize that. That's probably not ideal. I think it's probably best to let the final score be the main driver, where say it's a good intrinsic reward if it improves the final score. And if we're in this, if we make it all sparse rewards, if you don't give any rewards there, it might learn how to read the score and decide score going up is a good thing. And I'd be perfectly happy with that if the model found that out or if it hadn't found some other way. But score, in the end, is probably the right metric for us to be looking at. And if it doesn't improve score, maybe it's interesting theoretically, but it's probably not an actual good reward for it. Okay.
Can you hear me?
I can hear you.
Okay, well, that's pretty cool.
Yeah.
That's so fun. Hands up, can everyone hear me in the audience okay? There we go. I'll do just a quick intro. The minister doesn't need any introduction. My name is Aidan Kehoe. I'm the chairman of Beacon Data Centres, and it is a tremendous honor for me today to spend some time with Minister Glubish. We've been involved in the region here for a number of years, but I think maybe we'll start off, Minister. It'd be great to just give a little bit of background and context on your own kind of career pre-politics, because I actually think it's very relevant for lots of the conversations that we want to have and have had together. And what prompted your initial move into politics?
Okay, yeah, well, thanks for the question, Aidan. For those of you who don't know me, I'm Nate Glubish. I'm the Minister of Technology and Innovation here for the government of Alberta. And I was first elected in 2019, so I've been doing this for about 6 years. But before that, I spent 15 years as a venture capital investor here in Alberta, investing into all kinds of exciting, innovative technology companies and helping to build them from idea all the way to exit. And some of the, I guess maybe one of the more recognizable companies that I invested in was a medical diagnostic imaging company called Circle Cardiovascular Imaging. They're based in Calgary. And they came to me in 2010 and they said, Nate, we've got the world's leader in cardiac MR research, and we've got a bunch of really hot data scientists from the U of A and from across Alberta. And what we're trying to do is we're trying to use AI to completely transform diagnostic imaging for cardiologists and radiologists. And if we get this right, we'll be able to automate a lot of their workflow. We'll be able to increase their accuracy in the diagnosis. They'll be able to help more patients every day without having to work any harder, which is going to save the healthcare system money. So everybody wins. And I thought, well, that's a great value proposition. So we did our due diligence and ultimately ended up leading a $3 million investment into that company. And this was, again, 2010. This was 15 years ago.
Yeah. Where AI is called machine learning.
Yes.
Yeah.
Long before AI was like mainstream consciousness across the world. And so then, fast forward till now, their tools are now being used in 1,500 hospitals in 45 different countries all around the world. Their imaging technology is embedded in every Siemens MRI scanner that goes to a cardiac clinic worldwide. And they grew from 10 staff to over 100 staff, still headquartered in Calgary. and they just sold to a private equity fund for about $250 million. Wow. So, to me, that was a really exciting journey to be a part of. I led the investment. I got to be on their board, helped to shape their business strategy, and help them to get to where they are now. And but what really got me thinking about how this is a good segue into how did I get involved into politics. I looked at how they built that, and they didn't use a single Alberta healthcare data point to build it, to train their models. They had to go to all the teaching hospitals, cardiac teaching hospitals around the world, to explain, hey, this is who we are, this is what we're trying to do. Would you work with us to build an anonymized data set that we can train our models on? And they were successful in doing that. But I thought to myself, what a wasted opportunity. Imagine if Alberta's healthcare system and the Alberta government at the time had said, what if we could unlock some really revolutionary healthcare technology that will make our healthcare system more cost effective. It will build capacity in a constrained system, and it will create a really exciting technology company that's headquartered here and create a lot of jobs and attract investment. Imagine if the government of the day had just said, yes, let's find a way to make that work. Yeah. And so to me, that said, we could have hundreds of technology companies like Circle Cardiovascular Imaging here in Alberta if we figured out how to do that right. So one of the reasons why I decided to leave being a VC, run for office, and ultimately become a minister, is I wanted to bring my expertise as a VC, my expertise as an innovator, as someone who would invest in and help build tech companies. I wanted to bring that into public policy so we could start saying, how do we really add some significant momentum to our tech sector and turn this into a cornerstone of Alberta's economy, but not just for the benefit of the economy, also harnessing the world-class innovators that we have in Alberta and point them towards solving the biggest, most important, most meaningful problems that we care about as Albertans, like how do we make our healthcare system function better? How do we build capacity? How do we deal with wait times for cancer diagnosis and treatment? How do we deal with surgical wait times? There are ways to use technologies to help tackle these big problems, and if we do that well, then we can get the win-win of the best functioning publicly funded healthcare system in the world, as well as a thriving medical innovation ecosystem headquartered right here in Alberta. So that's a big part of what I'm trying to do is how do we adopt more AI in government, and how do we create essentially the necessary infrastructure to facilitate that type of innovation.
So you're deputy minister. I've had the good pleasure of meeting Yannick. When you think about the strategy for your office and also the amazing job you've done to recruit talent, what one was the vision for kind of how that got started, and how do you go about recruiting the talent into government like yourself, and what are the attributes you think that kind of get people energized to go build here? Yeah.
That's a tricky one to answer, and I don't think there's any one silver bullet on how do you attract the best talent into the public service. But for me, I think part of it was lead by example. As a minister, how do I set the stage of what's the vision? Where do we want to get to? And don't just come across it by saying, here's everything that's wrong with government, because that could be a very long list, and we could talk about that all day.
Well, it's also easy to say what's wrong.
But let's instead say, where do we want to go?
Yeah.
And we might have some things to overcome to get there, but let's start by saying, if we got here, could we all agree that that'd be a great story?
Great place.
And wouldn't that be fun to be a part of the journey to get there? And so I think, that took a little bit of time to help with trying to share that vision, and it's always a work in progress. But something that's been really helpful to me is we have been able to attract a couple of really great talented individuals into my team, into senior leadership positions. I see Sean Murphy in the back there. He leads our data center concierge team. He's one of my assistant deputy ministers. He joins us from Robotics, which is a $1 billion robotics company based in Calgary. And he left that company and said, I want to give back. I want to help modernize the public service and help bring some private sector expertise and insight into the government. And so we're grateful to have Sean. He's been a great addition to the team. And then back in October of last year, we attracted Janik Alford, my new deputy minister. He comes to us from FinTrack with the federal government. So FinTrack is the agency responsible for tracking money laundering and fraud in the banking system. And he was their head of AI. And what really got me excited about Janik is that, he's not someone who's been a lifelong bureaucrat in the public service. Not that there's anything wrong with that, but in addition to his experience in the bureaucracy, he's also had some private sector expertise, and he's also a technologist himself.
Yeah.
So he knows how to build AI tools himself and train models and just go and tinker with these things. And so having that insight and expertise has really helped us, not just on casting the vision, but also on executing. And we've been able to do more in the last 6 months with his help than I think in the last couple of years combined. And we're really just getting started. So I think by being able to tell some stories like that about some great talent that has come, share the vision of where we want to get to, and make it an inspirational story.
Yeah.
I think we're going to be able to bring a whole lot of really great people into our department, but we're also then training all the folks who are willing, who are within our department, to say, if you want to become an AI expert, we're here to work with you to help up your game. And so that's what we're really trying to do, is a full court press on elevating our skill sets with AI inside of our department and giving folks some really interesting problems to tackle and giving them the tools to go and do it in a neat way.
Yeah, it's amazing. First of all, it's fantastic. I think I flew in this week from San Francisco, where I had the good fortune of being at OpenAI this week, and staggering, the growth that's happening there. But one of the interesting things that I'd like to get your thoughts on is, this is not like when the cloud happened, it was like a top-down effort. We're going to take our infrastructure, we're going to move to the cloud. This is a very much a bottoms-up effort, where, everybody in this room is probably a user of AI themselves. And so what gets you excited about in the 6 months where you see the progress that you're making, of where you think AI can get adopted into government that probably wasn't possible, maybe 6 or 12 months ago?
Well, I can give you a couple examples of what we're working on right now.
Yeah.
Because I find sometimes instead of just talking in the abstract, you can say, here's something we've already done or are already doing. So in government, there's this concept of privacy impact assessments. And so as the custodian of a lot of data, whether it's healthcare data or data in the education system or data in the justice system or whatever it is, as a government, in the ordinary course of delivering public services, we become stewards of large quantities of data. And in the ordinary course of business, while we're doing what we do, often we have to develop a privacy impact assessment and file that with the privacy commissioner to basically just say, here's the best practices that we're going to follow. We're doing everything the right way, in an ethical and responsible way that respects Albertans' privacy. And normally it takes about 2 months of full-time effort to draft one of these privacy impact assessments and to make sure that it is compliant with all of the relevant legislation, regulation, and policy. Well, what we've done, and Janik was instrumental in this, is we've built an AI-enabled tool to help automate a lot of that process. And so now what we've done is we've trained that model on all the legislation, regulation, and policy.
Really cool.
To say, this is what a privacy impact assessment is in Alberta. This is what a fully compliant PIA is in Alberta. And then now what we can do is we can just go in and say, here's the definitions of the data sets that we're interested in the context of this privacy impact assessment. Here are the individuals in government, whether they're in tech and innovation, whether they're in health, whether they're in a different department. Here are the folks who are going to be working with that data. And you can load that into the system. And then we can go and say, here's the stated purpose for which they want to do this work. So it's not just like willy-nilly everybody can do anything. There's a very clear framework that folks need to follow. And you can upload all of this into the tool that we've built, and just with the click of a button, you have a fully compliant privacy impact assessment that's ready to go in a matter of minutes.
Wow.
So it's really exciting. And when you think about the fact that there are dozens, if not hundreds of these across all of government and across all government agencies developed every year, think about the amount of productivity improvements that you have, as well as the compliance improvement of to say, like, guaranteed that this is compliant with all the rules and regulations. So this is something that Janik was able to build real quickly. That's making a real impact already today. And then think about it beyond just the time savings on the generation of the impact assessment. Think about all the things that had to wait until those impact assessments were done before you could start doing the work. Now, instead of waiting 2 months to get started on something that's really meaningful and important and losing, a sixth of your year, you can start today. You have an idea today, you can generate a privacy impact assessment today, and you can start the work today. That's transformational.
Yeah, it's amazing. Time and money savings is extraordinary. And maybe, I know you were on stage a little earlier today talking about it, but I'd love to hear congratulations on the announcement with Google. Would you maybe we lean into that, the training piece? I just think it's a big, I think for those of you in the audience don't know, it's an incredible endorsement for Alberta that Google are making an investment like this. And maybe I'd love to hear a little bit more about that before we move on to the next topic.
Sure. Yeah. Well, we're super thrilled that Google has chosen to invest $5 million in partnership with Amii in order to develop some really world-class training materials targeted at a post-secondary audience on AI literacy. But it's not targeted at the computer scientists because, let's face it, they're already very AI literate.
Exactly.
But this is for the engineers, this is for the business students, this is for the agriculture students, this is for the social sciences, this is for every other discipline other than computer science to say, how do I up my game and understand what are the tools available to me and what are the responsible ways to use them? How do I do it safely and in a way that respects best practices? And so this is going to be great. It's going to really help us to develop some programs that we can launch all across our post-secondary systems across Alberta and really prepare the next generation of graduates with the tools they need to succeed in the modern age. And this is so I think one of the reasons why Google chose Alberta is because Alberta has been a leader in AI research for over 20 years.
Yeah.
I mean, a lot of that is thanks to former governments 20 years ago investing in the predecessor of the Alberta Machine Intelligence Institute. And I think I saw him here earlier today. I don't know if Rich Sutton's in the audience, but hey, Rich, good to see you. Oh, my mic is cutting out. There we go. But I remember it was in the early to mid 2000s that Rich was recruited to a research chair position here, and then again, this is all before my time. I can't take credit for this, so I can brag about it, but I can't take credit for it.
Good to brag.
But it's thanks to that leadership back then that we built this critical mass of really brilliant researchers and talent that have. Can I get another mic? This thing keeps cutting out on me if there's someone listening in backstage. But it was thanks to that investment that we've been able to build this critical mass of talent that is doing amazing things. And now Alberta is known the world over as a leader in AI research. And then you add to that some of the things that we've been doing recently on AI adoption inside of the public service, trying to lead by example and to show governments across Canada and around the world how powerful it would be to use these AI tools inside of government to deliver better services and better value for the taxpayer. Because if government can do it, then private sector can certainly do it. And so then that helps to hopefully that helps to inspire small and medium-sized businesses across Alberta and across Canada to say, well, if the government of Alberta can do it, then we can figure this out too. And it's just the headset? Okay,
yeah,
well then that's fine.
I'm able to hear you perfect.
So if we can do it, then surely they can do it too. And hopefully that will help to up AI adoption in the private sector that will drastically improve Alberta and Canada's productivity, which will be good for all of the citizens of Canada. And I think so Google is seeing all of that, and they've seen the work that we've been doing with our AI data center attraction strategy to try and say, well, all this AI adoption is great, but we need the compute infrastructure and the power infrastructure to power that compute if we want to see this happen at scale. So we've been trying to touch all the boxes. So the power and the compute infrastructure, the research, and then the adoption in government leading by example, hopefully leading to inspiring private sector to increase their adoption. You've got a full court press on becoming the most innovative jurisdiction in Canada. And so I think that was very attractive to Google. And so we're grateful for their partnership on this.
Amazing. And just, it was a lovely segue into a topic close to my heart, Alberta, as a world leader in the data center space. Take a step back a little bit about when you originally started to plant the seeds on the strategy, and then I'd also like to maybe touch on, because I'm not sure the audience might know this, but you spent such extensive time with the hyperscalers directly themselves, even going to visit and things like that. Give us a little bit of the background context of it, and then maybe walk us up to present day about why you're excited about it, and also like the reasons why Alberta is such a great place. I mean, we certainly believe it, but maybe just from your own context.
Yeah, sure. So this all started for me back in March of last year. There was an AI conference down in California, and you had a lot of the leading AI companies, OpenAI, Anthropic, of course, the household names, Google, Microsoft, all the big names. They were all there. And then you had all the researchers. I know Rich was there, and Yoshua Bengio was there from Mila, and several other brilliant researchers from all around the world were there. And there's a lot of just talk about what will the world look like 10 years from now, given the context of these the AI tools and technologies that we're building. And but as a part of that weekend, there was a segment where I know Dario from Anthropic, the CEO at Anthropic, was talking about how the year previous they had spent $1 billion on compute infrastructure. And then last year, when we had the conference, he was saying that year they were going to spend $10 billion. Wow. I thought, wow, that's a pretty big step change. And he said next year, we're going to spend $100 billion on compute infrastructure. And for me, that was the first awakening of, okay, there's something really big going on here, because Anthropic's not even one of the biggest household names yet. I mean, it's certainly better known now, but like a year and a half ago,
yeah, that's right,
they were still a challenger.
Yeah.
And then I had learned that Microsoft was going to be spending $200 billion last year on compute infrastructure all around the world. And I also talked to some of the Google folks, and I learned that out of all of their compute infrastructure, about 10% of it is being used to deliver all of their services, like Gmail, Google Search, YouTube, all the other tools that we all know and love. And 90% of their compute infrastructure was on training AI.
Yeah.
And so for me, those three stories that I learned that weekend really opened my eyes to saying, okay, this is way bigger than I ever thought. And there is an enormous global demand for compute infrastructure. And so I started asking around, I said, well, what are the biggest challenges to get to where everybody wants to go? And they said, well, it comes down to the electricity. We've already used up all of the grid capacity in North America and in all the low-hanging fruit around the world. So now it's going to be a question of who can build power generation fast.
Yeah.
Where can you build it fast? Where can you secure the power? Where can you have a good regulatory environment that makes it easy? Where can you get access to the raw materials that will generate that power, whether it's going to be gas or it's going to be nuclear. Or hydro. Those are really the only three technologies, at least in the near term, that can deliver the reliability that is needed. And so, well, we all know new nuclear and new hydro takes at least 10 years.
Yeah.
Maybe longer.
Yeah. If you get lucky with planning and zoning.
If everything goes right.
Yeah, right. Yeah.
So I knew for a fact then that natural gas power was going to play a big role as a bridge to nuclear over the next 5 to 10 years. So I started testing with everyone. I said, well, Alberta has some of the largest natural gas reserves in the world.
Yeah.
And we've got a government that is pro-development, a government that's all about red tape reduction. We're all about how can I give you the gift of time by giving you certainty and clear direction on what it takes to get an approval. So, I said, and then the third thing I said is that we've got decades of expertise in developing natural gas and turning it into power.
Yeah.
And so I said, if you had a jurisdiction like ours that could say we could make it super easy to develop the natural gas power, and that we could get fast approval times on the data centers themselves, if we can help you take something that takes 4 or 5 years to do and take it down to a year or two, how meaningful would that be? Yeah. And everybody said that would be a game changer.
Yeah.
So when I came back from that trip, I went and talked to Premier Smith, and I just said, you know what, Premier, I think there's something really significant here that's an opportunity for Alberta to be a big player in the AI infrastructure business. And so I was able to persuade her to give me a license to go and develop a strategy and to assemble a team of cabinet ministers in electricity, energy, environment, economic development, and a number of other files. And to play the lead role in saying, how do we make Alberta a destination of choice for hyperscalers, for the power generation industry, and to bring those two together to say, there's no better place in North America to build this infrastructure at scale. And so, one thing led to another, and we've been hard at work over the last year, and I think we're starting to see some of the fruit of that labor come to bear now.
I don't know if you've seen, for those of you who haven't seen it, Eric Schmidt, the former CEO of Google, he gave a TED Talk recently, and it just got released, I think, like a couple of weeks ago. And in it said, I see someone nodding there, he said, "Think Canada." And what he really meant to say, I think, was "Think Alberta." Because when you look even across Canada at even in terms of like the great capacity that's available, there's nothing available in Canada either, including in the US, as well as the same challenges that exist everywhere. When you think about the change that Alberta is going through from being an up and comer in the data center space to what we believe is you're going to be front and center in the AI development of infrastructure. One thing I think that I want to kind of touch on and lead into a question with you as well. What's very different about this versus cloud is there will need to be a huge build out of factory infrastructure for robotics. And we were just touching on robotics a little earlier when we were chatting. Like, what do you see as the progression? So it's like we talk a little bit about the data centers, but what do you see as the progression of the other industries?
Yeah.
And how can Alberta become, like, similar to what happened with the oil sands, how can we have like the AI sands infrastructure where we've got this like 20, 30 years of massive innovation and investment that we can bring into this economy?
Yeah, well, that's a great question because it helps to put into perspective that it's not just about turning gas into electricity, into compute, and then stop there.
That's right.
I mean, there's value in that.
Huge value.
There's great value in that for Albertans because it means we will be developing gas that otherwise stays in the ground. We will be turning it into something productive that is going to generate revenues to the province, which will fund important public services like healthcare and education. And we will create the compute, which will have great value for research, for private sector innovation, for government technology adoption, et cetera. But the real potential is the ripple effect that happens after that. And you sort of touched on some examples like robotics industries and others, is to say, what are all the industries that need compute? And where can they get compute at scale with a reasonable cost? Well, we have the lowest cost electricity in North America, the most reliable access to electricity in North America, and a pro-business environment where you can develop that at scale quickly, which means we could be one of the best destinations for AI data center capacity at scale. And if we are successful in doing that, then there are going to be companies who are already here, who need that compute, who will now have access to that compute, who can grow faster, create new things, solve problems in new ways with AI and new technologies. But you're also going to see new companies starting up that said, well, I had to start somewhere.
Yes.
My prerequisite was I need compute at a reasonable cost and at scale. And the most reliable place for me to find that was Alberta, so I chose Alberta to build my business. So I think you're going to see, if we are successful on the data center infrastructure side, you're going to see a huge boom of new technology platform companies, including in robotics, that will choose Alberta as the place to start and to grow and expand because they won't be able to get the kind of compute they need anywhere else. And then you add to that the fact that Canada is a very friendly jurisdiction, Alberta is a very friendly jurisdiction, and so you talk about sovereign compute. Talk about the sovereignty of whether it be government's data, or the sovereignty of an individual's data, or the sovereignty of a business's data as they're developing their new IP. Having everything resident here in Alberta, under the laws of Alberta, in a jurisdiction that is a very friendly and constructive partner in technological development. I think that's going to be a real lightning rod for success.
Yeah. So, as a person born in Ireland, it's not a surprise that you put someone called Sean Murphy in charge of the concierge program. So I'm very grateful. I'm very grateful for that. See Sean down there. Maybe because I think as a person who's been in the province and we've set up offices here. We've people who live here. We've employed people here, and we love Alberta. Maybe talk a little bit about the concierge program, how you put that in place, the reason you put it in place, and what have you learned from both the developers coming in and the hyperscalers, and what do you see as the pro is very kind of becoming clear about like the reason it's clear, but what challenges do you see that people are facing when they're making that decision? Because I think just for the audience's benefit, when we're developers on the ground here, we think of us like a developer representing Alberta. When we go to sell to a hyperscaler, we're competing with them choosing Alberta or another location. So we don't necessarily compete with anybody who's on the ground. We actually want more people to be successful in Alberta because it makes it a wider region. So when we think about it as a collective effort between both the municipalities, developers and government, everybody together. So maybe touch on just the concierge program, because I'm such a big fan of it and we've been a beneficiary of it. And also, share with the audience what you think the challenges are, both for developers and for the hyperscalers to kind of make this a destination.
Yeah, so for me, the reason setting up a concierge service to help companies like Beacon and some of your counterparts to get some assistance in navigating the approval process and the regulatory landscape. The reason that was so important to me is just, this is a complex business, and there's a lot of work involved, and there's a lot of moving parts, and there's a lot of different government departments and regulators involved. And I thought, you know what, we can play a connector role for the folks who want to build this infrastructure. If we believe that the building of this infrastructure is critically important and strategically relevant to Alberta's goals and objectives, then we can play a role to make it simpler and more straightforward for folks who want to come and do the actual building of AI data center infrastructure here. And so we wanted a one-stop shop where you could come and you could talk to Sean, you could talk to his team and say, here's who we are, here's what we're really good at, here are the things that we don't have expertise in and we were going to look for some partners and some help in, and here's our end goal of where we want to get to. How do we work together to try and make that a successful package that has a high probability of getting to a yes with the regulators, and where you're not spinning your wheels trying to figure out what to do next. I kind of used the term earlier, like, if we can give you the gift of time, time is money.
Yeah.
This way we can help deliver value without having to subsidize anything. Yeah. And so we put together a team that quickly, they were quick studies. They've become some good experts in the space. And then that way, if there's a question on environmental policy, we can go to the environment minister and to their team and bring them into the conversation right away. And when it's it's me and my team asking them to come, they come right away.
Yeah.
And so you don't have to waste 2 or 3 weeks trying to get an answer on one little thing. And then if you have a sequence of 100 different questions like that, where you save 2 or 3 weeks every time, it adds up.
Yeah.
But the other reason why it was important is because for this to be successful, we got to be smart about it. We can't just haphazard wander aimlessly through and just build data centers all over the province in random places. We have to be strategic, because the electricity demand for this infrastructure is so huge. We can't risk the affordability or the reliability of Alberta's electricity grid. Correct. If we do all these great things with AI, but we all of a sudden cause a significant spike in electricity prices, or we cause brownouts, then we will have let Albertans down.
100%.
And so that is a clear boundary, and we make this really clear to everybody as soon as they come to concierge. Affordability and reliability of the grid is non-negotiable. So whatever you want to do, it has to work within that confine. And so we can manage expectations. But then what we can also do is say, okay, well, how much infrastructure do you want to build? Are we talking like 100 megawatts? Are we talking 500 megawatts? Are we talking 1,000 plus? And then we can start saying, well, given what you want to do, here are some pockets around the province where the supporting infrastructure is already there.
Gotcha.
So that we can leverage that and optimize for that. Instead of saying, well, go build in some random place, and then we have to build billions of dollars of infrastructure to connect you. That's a non-starter. So our concierge team can help develop we've developed a bit of a site selector tool. It's a map, an interactive map that layers everything from natural gas resources and pipelines to electricity generation and transmission and distribution infrastructure to water.
I hope the beacon sites show up when you show them the site selection too.
and then we've got the water infrastructure, and we've got the fiber infrastructure, and we've got a whole bunch of things that are relevant to a decision-making process to say, where do we want to get our land, where do we want to build our facility. And so this way we can help to steer folks towards the optimal location, or at least to give them some options, to say, here's some optimal locations that are highly likely to work for you and highly likely to meet the province's regulatory conditions. So this is a bit of what the things that we're doing with the concierge.
It's fantastic. I think, and just so everyone's aware, we work, like Alberta is our main region. We do have other regions where we work, but we've never had a service like this. So grateful to you, Minister, for everything that you're doing. One thing, just for context as well, the good news is all of the customers who are coming into Alberta, they want two things. They want affordable power and reliable power. So the incentives are actually aligned. And one of the things that we're actually, as part of, we've got 4 PhD researchers in the energy sector that work with us. And if you look at typically how grids have gotten built over time, they got built for weather load, which is intermittent at different times of the year. And actually they're found that data center load, as it gets added to a grid over time, helps with stability, which is not a well-known fact because it needs to be 24/7, and also it'll lead to significant investment in generation, and it's predictable generation that allows people to build. One thing I wanted to touch on was, if you think about post concierge and like, I have a friend of mine who is the CFO of a large energy business, and he's building. So I think he's building somewhere in Texas, like it's an enormous LNG project. And their number one issue is housing, because these projects can go on for 20, 30 years. He said so many people have gotten married and had families and because they're on site. So maybe just talk about, I think, the second order effect. And we've had people, like I literally was on with our CFO. He's actually moving from Europe to Calgary and moving his whole family here because of what we're doing. He wants to be here, and because this is where the office is. So maybe talk a little bit just about the other kind of second order effects, obviously the growth in Calgary, and where you think the government, how is the government thinking about that supporting infrastructure as these projects get kicked off and developed?
Yeah, well, I mean, that sort of ties into the broader, just Alberta as a whole is growing.
Yeah.
Not just because of what we're doing on the data center file, but I think just folks from all across Canada are saying, wow, lowest taxes, best cost of living relative to the rest of Canada, really well-educated workforce. So if you're trying to start a business, you're going to find great talent here. There's so many draws to Alberta, and that's why we're the only province with net in-migration of people moving here from like, people are moving away from every other province, and they're coming to Alberta. Yeah. And we just passed 5 million people a few weeks ago, so that's a big milestone. So Alberta's growing, and with that come growing pains.
Yep.
So for us, there's a few things that we're trying to focus on. First of all, in terms of housing, we want to make sure that we stay a very relatively affordable place relative to Toronto, Vancouver, etc. And so what we've tried to do is to really focus heavily on our red tape reduction initiatives, especially when it comes to construction, especially when it comes to residential construction. And as a result, we are leading the country in the rate of new home construction. We're building homes faster than anywhere else in the country. We're getting approvals and permits for new builds faster than anywhere else in the country. And as a result, even though we're seeing significant growth, we're seeing some modest price increases, but it's not like getting completely out of hand. And we're just focused on trying to continue doing more and more of that so that we can keep up with that growth and maintain a cost advantage relative to other jurisdictions. We're focused heavily on building schools because, to your point, people come here, they want to work here, they get married here, they have kids here. Those kids got to go to school somewhere. And so I think it was last year we announced an $8.6 billion school accelerator program to build, the numbers I can't remember the numbers off the top of my head, but a significant number of new schools over the next 6 to 7 years. Because we know people, like Alberta's population is booming. There's a lot of young families, a lot of kids in school. We got to build that infrastructure. So we're investing in that infrastructure. And then, we know people are coming here, they need to access our healthcare system. So we're feeling some of the growing pains in our healthcare system. I mean, every healthcare system in Canada is facing some challenges. So it should come as no surprise that Alberta is as well. But what we're doing is we're investing in innovation in healthcare in a big way, and looking for ways to use artificial intelligence to help develop new diagnostics, new therapeutics, new ways to try and help build capacity, reduce wait times, and get people better care. And these technological investments are going to be completely transformative over the next couple of years that will help to bring that capacity so that we can say, when you're coming to Alberta, you're getting the best functioning publicly funded healthcare system in the world. It's only possible with technology. It's only possible with AI. So these things all go hand in hand.
Yeah.
And these are just a few of the things that we're doing to try and make sure that as we experience a bit more of a boom in AI data center construction and the associated infrastructure, and then the ripple effect of all the new industries that will be built as a result of access to that compute, we've been laying the groundwork for years already to prepare Alberta for that growth. And we're confident we'll be able to rise to the challenge.
Yeah. Where I grew up in Ireland, it actually is one of the main hubs for the cloud data center industry, and now a lot of the hyperscaler leadership are Irish, and in addition to that, there was all the the mechanical engineering of all built global companies that were based there. And Alberta has a history, like we do a lot of work with Stantec here, who are Alberta-based business. When you look out a little further and you look at like the barbell of the tremendous velocity and change that's happening with AI, the tremendous kind of infrastructure opportunity that exists. How do you think, as both a cabinet and really like a team in government, how are you going to handle and manage just the change in speed, how that's going to affect all your constituents, and like you as a leading government in the country and probably in North America, what conversations have come up in government, and how often does it come up?
Well, one thing that really excites me is our Premier really gets it.
Yeah.
Premier Smith understands how powerful the technology of AI is and how transformative it will be for everything.
Yeah.
One of my lines I've been saying since 2019 is technology is not just an industry, it's the future of every industry.
Yeah.
And it must also be the future of government. But, I would add to that today is that the most exciting technological advances today are AI driven.
Yeah.
And so what I love about Premier Smith is that she sees that. She's got the same vision. And so she's given me a license to really go and double down on technology. I mean, that's the whole reason we created the Ministry of Technology and Innovation. And a ministry like this never existed anywhere in Canada before.
Yeah.
And now we're starting to see more of that, right? Manitoba appointed a innovation and new technology minister.
They just swapped it.
Very similar portfolio to mine. And now the federal government has appointed an AI and digital government minister, which essentially has the same mandate as me. And so we're starting to see the rest of Canada recognizing that we need to get serious about adopting these technologies inside of the public service. Because if we don't, government is going to continue to move towards an unsustainable level. And then we got to make really tough decisions of saying, in order to be sustainable, we have to do less.
Yeah.
I would rather do more with less.
Yeah.
And the only way to do more with less is with technology.
Yeah.
That's how we accomplish more with less. And so that's what we're really focused on as a government. And so I get the role where I get to go and meddle in every other government department and say, how do we use some technology to do this better? How do we do some technology to do that better?
Yeah.
And so we're working with every government department on a regular basis.
Yeah. You mentioned, when you look at the change in the administration federally, how do you think that if you look into the changes in AI, because one of the things that's just very fresh in my mind is like I just came from OpenAI on Monday, and like I just think the pure velocity of change is like, it was eye-watering. It was funny. There's a friend of mine who works there, and she works in the account support department, and she said, I'm really worried about my revenue targets. And I was like, what do you mean? She wasn't worried about getting them, she was worried about handling them. You know, which you'd never hear any company worried about that before. But when you look at the changes that's happened in the federal government, and not to touch too much on the US relations, but you know, how do you see Alberta progressing, kind of leading more federally, and how do you see that relationship developing over time?
Yeah, well, look, I think one thing we can all agree on, regardless of which political stripe the different provincial governments are or the federal government is, we can all agree that more innovation is an important
100%.
Next step.
Yeah.
It's an important part of our future. And so I think to some extent we all want the same thing. We want a more innovative country.
Yep.
By being more innovative, we're going to have more economic development, more economic opportunity, better jobs, more investment, but we're also going to have better functioning governments.
Yeah.
And so I think, you know, we've been a bit of a leader in Alberta in this lately. I think over the next 12 months, there's going to be a lot of case studies we will be able to publish and share to say, we used AI to do this, we used AI to do that. You know, the example of the privacy impact assessment.
Yeah.
There's an example I could share if we had a little more time on something we're doing with technology procurement, because anybody who's ever tried to sell something to government probably knows it's a painful process. And you know what? AI can help us with that. So we're working on a very specific set of tools to facilitate government procurement. But then there's a ton of ways we can make our healthcare system function better. And so across the board, there's dozens of use cases that we're working on right now that over the next 12 months, I think we'll be able to tell that story, not just to say we're trying this, but to say we did it and it worked. And you can do it too. And so my goal is that we'll be able to lead by example as the best functioning public service in Canada, enabled by AI and new technologies. And then we'll be able to say, if you want to do it, we can help you do it. So, you know, and my hope over time is that will help to change the perception of the rest of Canada about Alberta. Because I think, you know, a lot of folks out east still think that we're just a one-trick pony in oil and gas. And that all we ever do is complain about pipeline access. Well, we do complain about pipeline access, but we're good at a lot of things here. And if we could go and say, well, we can help your healthcare system get stronger. And we'll help you do that. We'll share with you how we did it. And we'll help you to accomplish the same results. If we can go help Quebec, we can go help Ontario, we can go help Atlantic Canada. All of a sudden they're going to realize, you know what? Albertans are a really vital part of this country, and we probably should take some of their other concerns a little more seriously. So even though, you know, the intra-provincial trade relationships, that's not my wheelhouse, that's not my mandate, but the work that we're doing on leading the country in AI adoption, I believe we'll still have a bit of an impact on strengthening Alberta's brand across the country and helping us to develop more of a willingness among other provinces and among the federal government to say, hey, how do we try and get... Alberta's brought a lot of wins to Confederation. How do we help deliver some wins for Alberta? So getting near the end here, maybe a question for you, Minister. For me here with Beacon, like what are the things you think we can take from people who've been successful in Alberta over a long period of time? And do you have any advice for us as we kind of progress into our long-term relationship here in the province before we wrap up? Well, I saved the toughest question for last. I know. I would just say, you know, one of the things that I think is really special about Alberta is the entrepreneurial drive and the innovative spirit. You know, if you go back to what made Alberta so great when it comes to our energy industry, our oil and gas sector, we had problem solvers who were willing to work hard, do whatever it takes, be innovative, bring their ingenuity to the table, and just come up with new creative ways to solve problems. And as a result, some probably the most innovative energy technologies that are used the world over, their roots are in Alberta. And so I would just say, you know, what you can expect to see in Alberta as you expand your footprint here is that culture of innovation, that culture of an entrepreneurial spirit, that work ethic, that get-her-done attitude. And so I would say that if you're able to match that
Yeah.
then you're going to have a lot of fun here.
Well, I have had a lot of fun, Minister. I want to thank you for all the support your team, and the Premier has given us since we've been here. And I want to thank everybody for listening in to our chat today. Thank you.
Thanks, everybody.